Congratulations on your purchase of a Triton Workcentre. We believe you've bought the best value for money woodworking machine anywhere in the world. If you set it up properly, use it according to the instructions, and give it some occasional maintenance, it will look after you for years to come. This video is being made in May 1987. Now, it is possible that the machine which you have is somewhat different to the one being shown here. In that case, please use the manual which came with your machine, because it is specifically for the product you've bought. We as a company have a policy that whenever we design a new product or improve an existing product, we try wherever possible to make the new products or parts adaptable to earlier machines. So if you do have an earlier machine, please contact us, either direct or through your stockist, quote your serial number, and we'll be able to send you out some information on how to upgrade your machine. Our name, address and phone number are printed on the rear panel, as is the serial number of your Workcentre. We do recommend that you work your way through this video practicing all the cuts you'll see on some scrap wood. However, you won't be terribly popular if you bring your Workcentre indoors and do it in front of the TV set in the lounge room. Nor should you take your VCR and TV set out into the workshop unless you take some precautions against dust contamination of your heads and your tapes. Preferably, watch the video all the way through in one hit if you can handle it, taking notes as you go of the footage counter of your VCR for each particular segment. And then, when you're ready to do some cutting, you can quickly spool back, have a quick refresher course, and then go out into your workshop. Your Triton Workcentre will be capable of exceptional accuracy, provided it's properly set up, and provided also that the tools you've fitted, the saw, the router, and the blades and bits, are up to the mark. I don't propose in this video to cover the detailed assembly procedures. They're amply covered in the instruction manual. But I do want to cover some of the key points you should look for in assembling the machine and in operating it. First off, make sure that your Workcentre is securely mounted at a comfortable operating height. If you have an uneven floor in your workshop, use some packing under one or more legs of the Triton stand, or you may want to obtain from us some of these adjustable feet, which are now available to fit to your folding stand or to your extension table. In assembling the basic frame of the Workcentre, make sure you've got all the nuts and bolts in the correct way as per the instructions. Also make sure that the chassis is basically square, and the best way of checking that is to use a tape measure or a ruler and measure from outside corner to outside corner, and then compare it on this side, outside corner to outside corner. Those two measurements should be more or less the same, give or take a couple of millimeters. It is possible to slightly knock the chassis out of alignment when removing and refitting it to the folding stand, unless you do it the correct way. And the correct way is this. Firstly, remove the table. It reduces the weight and improves visibility. Secondly, always start at the end which has these bracing straps. Then put your foot in here, grab hold of both T-handles and pull up equally with both hands until the rubber feet come out of the tubes. Then move around the other end and repeat the process, trying not to skew the chassis as you lift it up. And then you can remove the chassis, fold away the stand. Vice versa, when putting it back together again, start at the braced end and finish off at the loose end. The rubber feet should be a snug fit in the tubes of the stand. If they're too loose, tighten up the rubber feet a little more, that'll swell them slightly. If they're too tight, back them off a little bit, loosen them off, or lubricate them. You've seen me using the plastic T-handles to lift the Workcentre out of the stand. Now, you can do that, but only if the T-handles are nice and tight. Otherwise, you might marginally shift your table position as you lift. Alternatively, you can put your foot in here as before and grab the Workcentre underneath and unplug it that way. If your basic frame is substantially square, then both of the locking keys should go in equally easily. Now take a fine point marker pen or a sharp pencil and fill in the letters stamped in the table as a reference point until you're more familiar with the different table settings. Now check the action of the slide chassis. Make sure it's a nice firm fit and yet free to slide all the way along. If necessary, use some spray lubricant such as RP7 or WD-40 or silicone and spray the open faces of both channels. When you receive your Workcentre, the slide chassis is adjusted for its minimum length. That may be okay for some 6.5 inch and 7.25 inch saws, But if you have a larger saw with a longer base, you may have to lengthen the chassis. That's done by removing these two nuts, perhaps relocating their bolts, and extending the chassis until the saw base can fit neatly between the vertical walls of the slide chassis. Just before tightening up the nuts again, check that this dimension and this dimension are the same. Then you can tighten up the nuts and fit your saw. Fit these saw clamping brackets as per the instruction manual, but just a couple of quick points. One of the lower saw locating brackets has a beveled corner, and that goes at the right-hand front corner of your power saw so that it can just miss this ledge. That only applies if you have a larger saw or with a wider base. Now at the rear of the saw, right-hand rear of the saw, you may find, especially with smaller saws, that when you angle the saw to 45 degrees, the top guard of the saw fouls on the bracket. Well, if that's a problem with your saw, then remove that bracket completely and replace it with this small hook-over clamp. This particular saw has a locking lever at the back here to lock the blade angle. Now, because that locking lever wouldn't normally clear the upstand of the slide chassis, I've had to introduce a gap between the end of the saw base and the upstand of the slide chassis and glue or screw a packing piece in there to prevent the saw ever sliding back on the chassis itself if the clamps loosen. This method of putting a packing piece in there is also needed if you've got a saw which has a very short base at the rear and the saw blade is in danger of actually hitting the slide chassis when you turn the saw by hand. Because I've introduced that gap, the radius on the edge of the saw base there would foul the normal use of the hook-over clamp, so I've notched out that corner there. If your saw has a fairly small wing bolt on the back, then an alternative to introducing the gap and the spacing is to file a small relief in the die-cast chassis, provided you don't have to go down more than 1/3 of that height. Finally, on the clamps, if you have a protrusion on the base of your saw that prevents you properly fitting one of the top clamps, remove the protrusion or hacksaw a corner out of the clamp. It's quite safe as long as you've got a fairly substantial amount of support on the saw base itself. Now attach some wire or string to the actuating arm of your saw guard and tie the guard back. Even though you don't use a saw's guard on the work centre, don't remove it altogether. You may one day want to use a saw handheld, and a saw without a guard is extremely dangerous. For the same reason, don't leave your guard permanently tied back. At the end of each day's work, release the guard and let it go back to its relaxed position. Otherwise, the spring will fatigue, and again, if the saw is ever used handheld, the guard will be worse than useless. Just a couple of quick points on fitting your saw blade. Firstly, before fitting the blade, make sure you've cleaned all the accumulated sawdust and resin from behind the saw blade on the arbor washer. Then fit the blade, tighten the arbor nut, but don't over-tighten it. Also, make absolutely sure you've got the blade on the correct way around. People often put them in back to front. The teeth must be cutting upwards into the wood when the saw is going around in its normal anti-clockwise direction. Don't be misled by the manufacturer's brand on the saw blade. As you can see from this example here, two brands on different sides of the saw blade. You can sometimes buy wobble washers, or dado washers they may be called, or a trenching head for your power saw. That effectively makes the saw blade wobble during a cut, giving you a wider cut. We do not recommend it. It'll wear out your saw very quickly and could damage the Triton table. Make sure your saw blade is set at maximum depth of cut, and then adjust the table upwards until the tips of the blade teeth are just entering the slot in the table, just a millimetre or so below the surface. Check it at this end, slide the saw at the other end, and check it at the other end. Now, you will see later in this video that there are occasions where you have to lower the table for cutting a thick piece of wood. You should very rarely have to raise the table, but if you ever do, make absolutely sure before doing your next cut that you've reset it to the correct position. Otherwise, the blade going too far into the slot can cut into the subframe bar underneath the table. Almost all power saws suffer from something we call saw slump, and that is the ability of the saw motor and blade to flex in relation to its base shoe. Now, with a higher quality saw, the saw slump is almost negligible. With a cheaper saw, it can be quite severe and cause inaccuracy in cutting. There are a few ways you can rectify the problem. Firstly, try to tighten up your own saw by checking the front pivot bolt and the rear pivot bolt. You may have to tighten the bolt and nut, you may have to put some shim packing in, You may even have to drill out a rivet and replace it with a bolt and lock nut. If you have a conventional type of saw, not a vertical lift saw, you may find if you've got excessive saw slump, it may be due to a small gap between the saw body and this bracket at the front. Well, that's fairly easily fixed by making a shim out of some thin sheet metal, say a soft drink can cut up, and remove that bolt, put the shim in, and then put the bolt back in. The other potential trouble spot for conventional saws is at the rear of the saw, where you may have a rivet through there which has become sloppy with age. Drill the rivet out, put a bolt and lock nut in its place. It's generally not possible to completely tighten up a power saw, and so you may find, especially when converting from the table saw mode to crosscut mode, that there's a very slight shift in the angle of the saw blade to the table caused by the weight of the saw motor. There's an easy way of fixing that. The first step is to convert the Workcentre to the table saw mode, because in this mode the table is not adjustable. Then use the adjuster on the front of your saw, the wing nut adjuster, to raise your blade until the blade is square to the table. If you're having trouble getting your saw blade square to the table, you may have to file a small amount out of the end of the slot in the quadrant of the saw, or failing that, you may have to place some very thin packing between the right-hand side of the saw shoe and the saw chassis, and that'll effectively tilt the entire saw over very slightly. Having got the saw blade nice and square to the table, now convert to crosscut mode. Follow the test cut procedures in the instruction manual and do a shaving cut on the end of a straight piece of wood. You'll probably find that along the cut you've got a perfectly square result, but across the cut you might find that there's a slight error introduced by the saw slump. Now, in the crosscut mode, the table is adjustable, so you don't have to fiddle with this wing nut on the front of your saw every time you convert between modes if you've still got a little bit of saw slump. What you can do is build a slight compensating slope into the table by lowering the left-hand side of the table, front and rear, by up to 4 or 5 millimeters to allow for that saw slump. If you've been unable to tighten up your saw adequately, you can obtain from us or from your Triton dealer a saw stabilizer bracket. Now, this bracket fits onto any power saw and very simply gives you the ability to lock the motor in relation to the chassis. For example, here we've got a lot of slump. The minute I tighten this knob, it's tight. The bracket also works when you're raising the saw blade for a partial cut. Slump removed. And when you're doing a 45-degree cut or any other bevel cut, the bracket tracks around with the saw and enables you to lock the motor firmly in position. With most saws, the trigger strap can be set the correct diameter by pressing this little nib here and setting it in the appropriate ridge in the strap. And then you can simply slide the trigger strap onto the point of the trigger and it should stay there quite happily. Before fitting the trigger strap, always make absolutely sure that the power to the saw is switched off, and preferably that the saw is unplugged. If the trigger strap tends to slide about on the shiny handle of the saw, then glue some sandpaper onto the back of the handle to give you some extra grip. If your power saw has a safety lockout button, push the button first, pull the trigger, and then slide the catch into position. If you're having problems with your trigger strap and you can't solve them in any of the ways just mentioned, you can obtain from us this Velcro type tape, hook and loop type tape, where you can slip it around the trigger, lash it firmly in position, and hook the tape onto itself. When converting to table saw mode, it's essential that one of these two lugs underneath the table locks the chassis in position and stops it from sliding. Your Workcentre may not have lugs like this. It may have spring catches. They perform the same function, but the way you use them is a little different, so consult your instruction manual in that case. The lug has to fit in the slot in the chassis. Under normal circumstances, you use the rear lug, the one furthest from the front panel, but you use the front lug when you're doing reverse angle miters or short taper ripping, as you'll see later in this video. Lock that securely in position, make sure the chassis cannot move, and then when you're happy with your position, remove the table and make some scribe lines on the bearing channels there and at the front position there, so that you can always line up your saw chassis prior to fitting the table. The next step, truing up the saw, is probably the most important step in terms of getting accuracy out of your Workcentre. If you followed the instructions correctly, by the time you get to this point, the saw will only be loosely clamped onto the slide chassis. Okay, first make sure that the blade is exactly square to the table. Then set the fence in its slots, lock the fence off at 0, and then by reaching underneath and pulling, pushing or twisting the saw, you can adjust the saw until the teeth of the blade are just scraping lightly against the fence. Still free to move, but lightly touching the fence front and back. Next, fit the riving knife and safety guard behind your saw blade. There are 3 positions for the clamping bolt. The central position is for most saws, the forward position is for very small saws, the rear position is for very large saws. The idea is to get a gap of about 12 millimeters or half an inch between the back of the saw blade and the leading edge of the riving knife. Here's a very important point. Whenever you're fitting your riving knife, make sure your saw blade's at full height. See, at the moment my blade is not at full height. If I raised it, I'd be cutting into the riving knife if I accidentally switched on the power. So set the riving knife when the blade is actually at full height and you'll avoid problems. Now take 2 short straight pieces of wood and place them on either side of the blade until they're neatly touching the blade on both sides. Check that the riving knife fits within the gap between the 2 pieces of wood. It's not essential that the riving knife be central in the gap, but make sure it's clearly within it. If you have an ultra-thin slitting blade, you may find that even though you've got the saw blade touching the fence when the fence is set at 0, the riving knife and the blade are no longer in line. Well, what you have to do there is adjust the saw clamps so that you can move the saw slightly away from the fence, get it in line with the riving knife. That will, of course, introduce a small error in the calibration scales of the fence, and you'll just have to allow for that when setting up the fence for cuts. Check either visually or with a square that the riving knife is exactly square to the table, and also check that the nose of the riving knife is not sticking up proud of the table. It must be slightly below the surface. If it's not, file it down a little bit. Double check that the fence locks properly. Lock it off firmly at any position, and then push or pull quite firmly at both ends to make sure the fence is securely locked. Incidentally, some lubricant inside these threaded tri-knobs will help in making them twirl up easily. Then check that the safety guard rises and falls freely. Again, you may try some lubricant on the riving knife or some talcum powder perhaps. And check that the mitre gauge, the protractor, is a nice, firm, smooth slide. Again, lubrication on the aluminium strip, and check it all the way through its range. If it's tight at any one point, the best thing to do is to take a file or some sandpaper, remove the table, and remove a little bit of the epoxy coating off the walls of the slot to make it free at that point. If it's loose all the way along, the instruction manual will show you how you can spread the strip underneath very slightly to make it a tighter fit. If it's tight all the way along, again the manual will show you how the jaws of a vice can squeeze that strip in slightly. Make sure the slide chassis is locked firmly in position, the saw guard and riving knife clamped down to the table, the blade is free to spin and not touching anything, and then you can switch off the power, just bump this red plate, plug the power saw in, and you can test out the switch and the trigger strap. Switch on. The first thing to look for in selecting a new saw is blade diameter and depth of cut. For you see, in the table saw mode, there is some loss of depth of cut, which means that a 7 1/4 inch saw, if it's fitted with a 7 1/4 inch blade, not a 7 inch blade, will just make it through some 2 inch dress material in the table saw mode. For that reason, we generally recommend that an 8 1/4 inch saw or slightly larger, 9 1/4, is advisable. The next thing you should check for is arbor float. Now that's the ability of the saw blade to move sideways on the main shaft. The way to check for it is to either grab hold of this nut and see if it moves in and out, or pull the whole saw blade and see if it moves in and out. You should look for a tight saw. Now look for a saw which has accessible knobs for locking or adjusting the saw blade, front and rear preferably. Make sure the knobs are easy to get to and lock firmly. The saw itself should preferably have a fairly stiff base, not subject to flexing, and it's not important whether the saw has a riving knife or not because the Workcentre has its own. We generally do not recommend vertical lift saws because of their difficulties in plunge cutting, and also some vertical lift saws, especially when they're raised, are quite wobbly on their base, except if they've got a rear support bracket or the Triton saw stabilizer bracket. In selecting a saw blade, perhaps the first thing you should ask, should I get a tungsten carbide tipped blade or not? Well, the answer from our point of view is clearly yes, you should. For the following reasons: carbide tipped blades cut much cleaner and faster. They give a smoother, less splintered cut, less ridging on the cut. They stay sharper much longer, between 50 and 200 times as long as a pressed metal blade, and they are resharpenable, so if you do ever blunt a carbide tipped blade, by all means get it sharpened. The next question is the number of teeth you should get. Now, as you can see, there's a wide variation. Here's a 60-tooth blade and a 24-tooth blade. Generally speaking, if you can afford two blades, then get a finer blade for doing your cross-cutting and a coarser blade for doing your ripping. Because when you're ripping, especially, the gullet behind each tooth has to be fairly large to accommodate the sawdust or swarf that's created. And in ripping, the swarf is in long curls rather than short pieces, so you need a fairly large gulleted saw, or you have to adjust your feed rate accordingly. If you've only got a fine blade, a fairly fine blade, you can use this for ripping, but don't try to overload it, don't feed the wood too fast. Another consideration is the thickness of the saw blade that you're getting. Now, as you can see from this example, you can get thin blades and you can get thick blades. The thin blades, or slitting blades, are recommended when you're working with a saw which has some saw slump, some movement between the motor and the saw base, because the thin blade has less load on it, it's removing less material, and any inaccuracy in your saw is less likely to show up. If you've got a tight saw, however, a thick blade is better, because it won't tend to wander with the grain, it'll cut straight, plough its way through rather than deflecting during a difficult bit of cutting. We generally don't recommend the use of arbor reducing washers unless they're a perfect fit in the saw blade. As you can see here, there's a step between the washer or the bush and the blade. That can cause a problem. If the bush is too tight, it'll cause the blade to buckle. If it's too loose, it can cause eccentricity in the blade. If you are using a reducing bush, make sure the washer, the flange washer which clamps the saw blade onto your power saw, is bigger than the bush you're using. Having decided basically what sort of blade you want, how do you pick the better quality blades from the worse quality blades? Well, there's quite a lot in it, but here are a few quick pointers. Firstly, look for a saw blade that has as its basic disc hardened steel rather than a mild steel. And you should tell that from the packaging of the blade. If they're using hardened steel, they'll boast about it probably. Secondly, look for grinding marks. Look for signs that the blade has been ground on both sides, and look closely at the teeth, and you should be able to see very faint grinding marks on all the sides of the teeth to make sure that they've been surface ground, both sides. And the better quality blades, the teeth are also ground on the tops and on the faces themselves, so again look for those little scratch marks. Now, some of the better quality blades have expansion slots in them, and those expansion slots allow the saw blade to heat up slightly during a cut without buckling, because any increase in circumference is taken up by the slot itself. Similarly, the better quality blades after saw doctoring are tensioned. They have a tension ring knurled into them, and that again helps the blade stop deflecting during a cut. Now, whatever blade you decide to get, check through the range available in the store and check it this way. Get a straight edge, take the blade out of its packaging, and check with the straight edge across the centre at various points that that blade is dead flat. Check it at several points and make sure. Now, that is very important, so check it, because some blades from brand new aren't quite right. If for cost reasons you've decided you can only afford one high quality blade, then you may have to compromise on the number of teeth. As a rule of thumb, a 7 1/4 inch saw should have about 30 teeth, an 8 1/4, a 9 1/4 inch saw 40 to 60 teeth. One last thing about saw blades: keep your blades in good condition. This blade was taken off one of our customers who complained that his Triton wasn't cutting accurately. Well, the answer was quickly identified. The blade's rusty, it's not flat, it's buckled, and there's not a single carbide tooth left on this blade. Every single tooth has been smashed off. No wonder he couldn't cut properly. So with your saw blades, keep them clean, keep the resin from accumulating on the blade and wash it down. Mineral turpentine and steel wool is a good combination to get the resin off the blades. Look after them, keep them sharpened regularly, and if you lose a tooth or two by hitting a nail, for example, get it re-tipped. It's not expensive. A lot of people don't know how to check a tri-square. Now, here's a very simple and infallible method of checking it. get yourself a board with a nice straight edge. That edge has to be absolutely straight, so check it first. Then place your square hard up against the straight edge, use a sharp pen or pencil and draw a line. Then turn the square over, hard up against the edge again, and compare the blade of your square with the pencil line. If they're exactly parallel, then your square is absolutely accurate. If they're not, any error in your square will appear as doubled because you've turned the square over. And if you're going to the hardware store to buy a new square, I suggest you take a board with you and a pen or pencil and test the ones they've got in stock, because a lot of squares from brand new are inaccurate. Most of the jigs used in this video have been drawn up by us and are available in plan form in the Triton project book. Just before starting work, a few quick safety points. Firstly, always work in a well-lit and uncluttered environment. Avoid scraps of wood underfoot, piles of sawdust and tangled power cords. You could trip. Secondly, protect your eyesight. Wear safety glasses, preferably the wraparound type. If you're working in natural light or a mixture of natural and artificial light, then use a clear type of safety glasses. If you're working purely in artificial light, the amber tinted glasses will give you better contrast. You should also consider getting a pair of earmuffs, especially when using the router for sustained periods, because the sound of the router can damage your hearing over a long period of time. And a dust mask. Very cheap, very easy to obtain. Wear one of these whenever you're cutting tiles or bricks, and there are certain types of wood that you shouldn't cut without using a dust mask. The problem with certain types of wood mainly comes up when you're sanding them, creating very fine dust particles, or burning the wood. But here are some of the materials which can give you problems if you inhale the sawdust or come into contact with it. Black bean, silky oak, cypress pine, some species of mahogany, blackwood and spotted gum. Pine treated with copper chrome arsenate can be a health hazard if you sand the material over a prolonged period or burn the offcuts or the sawdust. You should declare your workshop off limits to children and pets. They could disturb you during a cut and cause an accident. Or they may gain unauthorised access to the workshop when you're not there and also have an accident. So for that reason and for another couple of reasons, when you're finished working for the day, disable your work centre. Release the trigger strap. That will prevent the spring in the trigger from fatiguing, and untie your safety guard and allow it to swing back to its fully closed position at the end of the day. Again, that will protect the spring in the safety guard. You have the choice in this mode of operation of either using the trigger on the saw or not using it. Using it, naturally, you leave the power permanently switched on and you just squeeze the trigger when you're ready to cut. However, we do recommend that you switch the power on the machine off, switch off at the switch box, use the trigger strap to lock the trigger permanently on, and then control the power from the switch itself. The reason for doing this is that very often, and somewhat unconsciously, people do twist their saw when they're pushing it forwards and backwards. They twist their saw as they're grabbing the trigger, and so it's generally better to leave it locked off and just slide the saw by holding the rear of the slide chassis safely well away from the blade, and you can control the saw's traverse without worrying about whether you're twisting or not twisting the saw. Most people are used to using a power saw in their right hand and holding the wood in their left hand. Quite the opposite is the case with the Triton. You hold the wood with your right hand against the fence and you push the saw with your left hand. Because basically with a power saw on a Triton, you really only need one finger to push it. So use your stronger hand, the right hand in most cases, to hold the wood firmly. One of the best ways is to bunch your fingers together and push on the back edge of the wood, the edge closest to you, and push it down and forwards into the workstop. And that way you can hold the wood. You may prefer to wrap your hand over like that, but make sure that your thumb doesn't protrude too far underneath the bearing channels. In fact, as a good rule of safety, try to keep your hands outside the bearing channels at all times. It's very important, if you want some accuracy in your cross-cutting, to work with very straight pieces of wood, and make sure that the face which is held against the workstops, these two workstops, is absolutely straight. Hold it down there, make sure there is no sawdust between the wood and the work stops, because of course that will pack the work out from the work stops. Press it firmly down against the table and against the stop, and then you're ready to make your cut. Another word of warning in your selection of material: try to avoid cross-cutting or indeed ripping through any knots, because a loose knot like this especially can shatter during a cut and a piece could fly out and hit you or get you in the eye. The next step is cutting accurately to a line. Okay, well, mark a line on the face of the piece of wood you want to cut, and let's call this small piece the waste piece. Obviously you don't have to square your line all the way around, just one face will do, or even just a simple mark will do. Place the wood in the work centre with the straight face against the work stops, and have the pencil line roughly halfway above the centre slot in the table. Now you can open this side guard here and move the saw in until the blade is just touching the line. Turn the blade around if necessary until the tooth is just at the right spot, and then move the piece of wood in sideways, inch it in until the blade appears to be parked perfectly on the waste side of the line. Now there's a very important point here. You must never switch on the power while the saw blade is touching the piece of wood in any mode of operation. Always back the saw off slightly until you're well clear of the wood before switching on the power. Now give the saw a brief burst of power, and as the saw is coasting to a halt, you can do a little test nick on the edge of the piece of wood, just like this. Hold the wood firmly, don't move it. As you can see there, the saw cut is exactly on the waste side of the line, and now without moving that piece of wood, I can now go through on full power and make the cut. If I wasn't happy with the position of that test nick, then of course I could marginally adjust the wood left or right slightly until it was in the right position and then make the cut. In making this cut, I'm going to be creating a smallish offcut, but not too small. That's sitting beside the side of the saw blade. Now that can have very serious safety implications, so have a look at what I do. I made the cut and then allow the saw blade to stop spinning while the saw is parked in its fully extended position. If I hadn't done that, this offcut may have vibrated slightly sideways and the back of the blade may have smashed it when I was pulling the saw back, still spinning. So get into the habit right now of never pulling a spinning saw blade back onto an offcut. Generally speaking, you should try to avoid situations where you'll be creating an offcut of this size. If you're doing test cuts, for example, just take shaving cuts off. Just take off one blade width or a little more than one blade width, and the paper thin shaving won't cause you a problem. Having said that, you may see me from time to time in this video doing what I've just told you not to do. In other words, pulling the saw back on an offcut. I'm taking a risk because I'm trying to save a bit of time in explaining these cuts, but don't do it. Get into the habit now of never pulling back a spinning saw blade onto an offcut. A couple of very quick points about your feed rate. You shouldn't jerk the saw into the wood. You should push it smoothly and evenly all the way through, and of course never force a dull blade to cut. Get a sharp blade. Apart from the feed rate, there are a couple of other ways you can minimize splintering. Firstly, in the crosscut mode, have your good face downwards, because splintering is greater on the face which is uppermost. So turn your work face down, and secondly, have some backup at the point where the blade cuts through. And the backup is best achieved by having a straight piece of wood screwed to your work stops. And you've got screw holes in the work stops, and just get any straight parallel-sided piece of wood, screw it on, preferably a wide piece. You'll see this is quite useful for a few cuts, but also the very fact of having the wide piece in there on your work stops means that the work is brought that little bit closer to you, and it does minimize a bit of back strain when you're cutting continuously. The very first cut you make through here will turn this into two separate pieces of wood, both screwed to the work stops, and will give you an excellent sighting point for future cuts, like this. Now you can take any piece of wood which has been marked, place your pencil marked piece right against the edge of the slot, and you can sight up your cuts beautifully simply without looking down through the guard. One important point not covered yet is support for your workpiece. Up until now I've been cutting nice short pieces of wood, but what happens if you're cutting something very long? Well, then you must support the pieces which are hanging out of the work centre. If you don't, once you've made the cut, they will drop, perhaps damage your work centre, and certainly can pinch against your blade and damage your saw blade. So make sure you've got good support for your workpieces, especially long ones. The Triton extension table is an excellent way of supporting them. You can either have the extension table clamped up alongside the work centre, or you can have it freestanding as far away down your workshop as it needs to be, depending on the length of your workpieces. Another method of supporting long beams in cross-cutting is to make up a trestle like this. You'll see more of this trestle in the table saw mode, where you'll see how to use this top surface for supporting large sheets. But at the moment we'll be using this member here, which you should make adjustable up and down, because you might not always be cutting material at the depth of cut of your saw. You might one day want to cut some 4x4 or 6x6 even. So make this either clampable or adjustably screwable. And as far as the base of it goes, you may, if you've got a small workshop, you may want to consider hinging that and making two demountable props so that you can store it more easily. And now you've got excellent support for your long beams during a cut. One of the most useful cuts you can do with the work centre in this mode is to multiple cut. Now, every table has 4 legs, and of course you want them all exactly the same length. So how do you cut 4 pieces or 6 pieces to exactly the same length? Very simply. Cut them a little bit longer than you'll need, and then get your dressed ends, the ends you've just cut, which are nice and square, and have them dead in line on the outside of the machine, like this. And you can tap them into position and just run your finger along there, or use the back of your square to make sure they're exactly in line. Okay, now I find that ducting tape like this is much better than masking tape. It's not very expensive, it's much wider, and it's got good adhesive on it. So once you've got your 4 pieces in line, tape them together, just like so, without moving them. And then, of course, the 4 pieces will act as though they were one piece of wood, and when you cut through them, they'll all be exactly the same length. Clear the table off. It's very important that you have nothing on the table except the wood you're going to be cutting. And then you can move the 4 pieces taped together into position, do another test cut if you wish, so that they'll all be exactly the same length and exactly the right length. Sight that up, that looks fine, and then through you go with 1 cut. And there you have 4 table legs, all exactly the same length. Say you need 8 pieces the same length. Well, take one of the pieces that you cut in your first batch, and this is the correct size that you want to end up with, and call that your master. Rough cut another 4 pieces, for example, as shown earlier. Line up the dressed ends and tape them together so they move as one block. Then put your master in and line it up also with the outside end, so that the dressed ends are dead in line, all 5 of them this time. Move the saw in until the saw blade is exactly opposite the 5th piece, the master. And then you can slide the whole lot sideways until the master just touches the saw blade. Make sure you're not deflecting. Pull the saw back and move it in. Back it off slightly if you have to. A whisker. That feels just right. Then remove your master, put it aside, and you can cut your other 4 pieces to length, exactly the same length as the master. Another good way of cutting a number of pieces the same length, especially fairly short pieces, is to use the rip fence that comes with your work centre in the 2 slots. Now you have to turn the rip fence around to fit it in the slots and still keep the work stop in position, but that's fairly simply done. Bear in mind also that the calibration scales are used only to make sure the fence is parallel, because they won't give you a real dimension. Now, in this sort of cut, it is absolutely vital that you don't pull the saw blade back on the wood while it's still spinning, because you'll have 4 small offcuts, and these are the pieces you want to keep. You're making a breadboard, for example, and you want these 4 pieces, so do not pull the saw back onto them. Let it stop once you've finished the cut. Once the saw has finished, you can remove the pieces. There you are, they're as good as gold. They may suffer some very, very slight recut damage because they're sitting against the side of the spinning saw blade, but that's very easily sanded off. And of course, all pieces cut this way will be exactly the same length. You can also get an excellent result cutting a number of short pieces to length in the table saw mode. You'll see that shortly, but it's the mode you should use if recut damage by the side of the spinning blade is causing you a problem. A very useful length gauge you can make yourself is made like this. A straight piece of hardwood preferably, screwed to both work stops, and then the first cut you make will give you a permanent sighting point for future cuts. You line up your pencil mark with that point. However, if you make this gauge properly, you don't need pencil marks anymore because you can glue a self-adhesive ruler on the top, or you can rebate a metal ruler or a wooden ruler into the front, whichever you prefer, and then it's a permanently accurate length gauge. All you require then is this small block where the end grain of this piece is flush and perpendicular to the edge of this piece. Then the block just sits on there and can be G-clamped in position to give you the exact size cut you want. Now you may find that this length gauge won't go back into the same spot if you do remove it and refit it from your work stops, because the holes provided in the work stops are probably slightly larger than the screws you'll be using. Well, there are 2 ways of zeroing your gauge once you've removed it and refitted it. One of them is to loosen off the screws and push the gauge slightly sideways until this edge just touches a saw blade, and then tighten the screws. Alternatively, you can drill a very small hole or perhaps a couple of holes in the work stop, drive a nail part the way in, and then snip off the head of the nail, and that will act as a permanent dowel for removing and refitting. An extremely useful construction joint is known as a trench, or a housing joint, or a dado, depends on which country you come from. And basically, it's just a slot cut crossways across the grain in a piece of wood to house another piece into it. It's very strong and very simple. Here's how it's done. Firstly, you have to raise your saw blade. Don't lower the table, raise the blade using the adjuster on the portable saw. Now, you don't have to crawl underneath with rulers to try and measure the distance that you're raising or lowering the blade. There are a couple of very simple ways of doing it. Firstly, a simple pencil mark on the end grain of the piece of wood you'll be using, or an offcut of that piece, placed in there. Then you push the saw in, and you lower the saw blade until the lowest tooth is just up against the pencil line. Perfect, that's set. There are a couple of other ways. Firstly, using a piece of the wood you'll be using for the job, set the blade approximately to the halfway point, make a cut, turn the wood over, and make a second cut, having moved the wood across very slightly, say 3 or 4 millimeters. When you reach the point of blade adjustment where those 2 cuts would just meet if they were in line, that is your halfway point. There is another way as well, and that is to make up a simple setting block where you have a square dress block with a couple of rulers, or perhaps just one ruler, metric and imperial we've got on this one, but rulers rebated in where the 0 position is flush with the bottom of the block, and then of course resting this on the table will allow you to set your saw blade height to a known dimension above the table. Now there's another very useful feature once you've set your saw blade height of using the Triton for rebating, and that is you can do 2 or 4 pieces at a time. Tape them together if you wish, or if you're only doing 2 pieces and they're reasonably narrow, here's a very good little tip. Take your pieces and take a parallel-sided piece of scrap material that's fairly thin, thinner than the work pieces you'll be using. Place that against your right-hand work stop. That brings the work a bit closer to you to eliminate back strain. And it also enables you to hold the pieces on the table. Oops, I've got something rocking there. Hold the pieces on the table, get the ends dead in line, and actually wrap your hands around the two pieces and hold them firmly so you don't have to tape them. Then you can line up your cut as shown earlier, touch the saw blade against the pencil line that you've made, do a test nick if you wish, like this. Just adjust very slightly. Perfect. As you can see, by doing the two pieces together, I've created two identical rebates or dados or trenches. They're the same depth, the same distance from the end, and the same width. And if I'd had four pieces in there, I would have done four identical pieces. You don't have to measure and mark each time. Just mark the defining cuts of the piece closest to the saw blade. You don't even have to do that, as you'll see in a moment. But now an important hint when rebating. Try not to make your rebate too loose when you start off, because you can always open it up a little bit. It's a bit more difficult to close it down. So do a test fit when you're close to the position that you think you need to be at. Yes, that's a little bit on the snug side. So here's how to open it up very simply. Put the pieces back into the work centre, clearing the sawdust away. Put the pieces back. Park your saw blade in position in the trench you've made, and push the wood sideways until you're slightly deflecting the saw blade, just very slightly deflecting it. Then pull back. When you come through under power, you'll now do a finishing cut, and you'll just skim off a small amount, widening the trench slightly. There we have it, a perfect fit. Incidentally, a very excellent joint you can make is called a post and rail joint, where those two pieces are glued face to face, and then of course a rail can fit in there beautifully, and you've got post and rail type construction for a chair leg or a table leg, for example. A couple of small operational hints. Firstly, when you're making this sort of joint, always make the cut, pull the saw back, and then move your piece of wood. Don't try to move your workpiece while the saw blade is within the trench itself. And secondly, if you find it difficult to inch the wood sideways as you're doing the cut, then try this. Park your hand right there so that the edge of your hand is levering against the bearing channel, and then use that as a reference point and a steadying point so that you can lever incrementally across and make the cuts very neatly side by side. Another operational hint: if you're making your trenches and they're symmetrical, for example, one there and one there, the same distance in from the ends in both cases, then you can fit your fence to the work centre, reverse the fence and fit it as a stop, and then you simply butt the work up against the fence, make a cut. Then you would reset the fence by the width of the trench that you want, and make another two cuts, defining cuts. They're the outermost cuts of your trench, and then simply remove the waste. You'll notice there's no problem when doing a trench like this of pulling the saw back, because you're not actually creating a solid offcut which is going to be trapped between the blade and the fence, because this part is still connected to the main piece. So there's no danger of recutting that offcut on the pullback. If you have a saw which has a very long base, then you may find when doing a trenching cut that you end up with a slight curvature at the end of the cut following the radius of the saw blade, the curvature of the saw blade. There's a very easy way of rectifying that, and it's to fit a couple of fence packers to your work stops. They bring the work closer to you and eliminate that curvature. Let's say you want to house a board into a beam, and the beam is too tall to normally fit between the table in the normal position and the aluminium bearing channel. Well, no problem, you simply drop your table. Before dropping it, make a mark there, and on the front end of the machine to tell you where to reset your table when you go back to normal position, but then simply drop the table equally at all 4 points until you can admit your tall board, and then you can do your fine-tune adjustments for the depth of the trench by using the saw adjuster itself. A safety point. When using a tall board like this, we do strongly recommend that you fit extension fences to your work stops. They give you plenty of vertical support as well, of course, as a sighting notch. The Workcentre will give you a cross-cut capacity of anywhere between 450 mil and 600 mil, 18 to 24 inches, depending on the size of saw you fitted, the length of the saw specifically. Now, there will be instances, no doubt, where you'll have a board which you want to cut in the cross-cut mode, and it simply won't fit because a saw blade gets in the way. Well, there's a fairly simple way of making this cut, provided your saw has a very smooth and yet firm rise and fall action. Every saw can benefit from a little bit of lubricant sprayed on the slotted arm, and some saws, in fact, may have to have a larger washer inserted between the clamping arm and the slotted arm or the slotted bracket. But make sure your saw can rise and fall smoothly without too much wobble as it's rising and falling. For that very reason, we do not recommend that this cut be done with a vertical lift saw. The problem with a lot of vertical lift saws is that they only tighten up when they're finally clamped, and that sort of wobble as you're plunging down, because that's what you'll be doing to do this cut, will throw you out in accuracy and perhaps cause a safety problem. So this cut should really only be attempted with a saw that has a firm action. Very simply, all you do is you raise the saw blade, like so, lock it in position, position your wood underneath, sight down from above, and you can actually lower the stationary saw blade onto the pencil line you've made, position your wood finally, close the guard, then raise up very slightly, switch on, and there you can cope with a wider board than you can normally cut. What happens if you've got a very wide board, up to in fact 27 inches wide or 675 millimetres? You can do this very same thing, a plunge cut, but you'll be doing two plunge cuts, because even with one plunge cut you would still have a small section uncut of the material. Before doing this cut, make absolutely sure that this edge and this edge are absolutely parallel, because they have to be. Raise your saw blade again, position the wood underneath, line up your blade with the pencil mark, again switch on using the trigger and then lock off once you're in the down position. When the saw has stopped, raise the blade, move the workpiece out, turn it end for end, and this is why it's important that these edges be parallel. Park the wood back in the approximate position, line the saw blade up and drop it down into the cut you've just made. Drop it down there. Finally position your material so you're not deflecting the blade at all. Move it backwards and forwards, that feels fine. Those of you who have ever used a radial arm saw will probably be scratching your heads in bewilderment at the method used for cutting with the Triton. A radial arm saw, as some of you will know, cuts with the back of the blade leading into the work. With the Triton it's the exact opposite. Radial arm type saw cut is a climb cut. We're doing a feed cut, and the feed cut is definitely the recommended method. However, there are some instances where you may want to use a climb cut. For example, a long piece of moulding, cornice or architrave, for example. As I mentioned earlier, you want your good face to be down to minimise splintering. Now obviously you can't rest this safely and securely on its good face down. Okay, so with a piece like this, you want to cut it with the good face up so it can rest securely on its flat back with the square side against your work stops. And you want to do it as a climb cut so that you're not splintering this top face. The way to do it, very simply, pack out your work stops so that you can start off with your saw blade completely parked behind the work stops. Then you can slide your piece of wood in on its flat square base and cut with the back of the blade. A couple of very important points. Firstly, you must have a sharp saw blade, preferably tungsten carbide tipped. Secondly, the mechanism which locks your saw down must be very secure and firm. Tighten the lever or tighten the wing nut very tightly. Thirdly, you must control the rate of feed of the saw, because this is a climb cut, called that way because the saw will tend to climb up on the work, and unless you're controlling it rigidly with a firm wrist and a firm elbow, the saw will race towards you, biting off more than it can chew in effect, and it'll damage your blade, it'll damage your work, and certainly damage your confidence. So hold the wood against the work stops, packed out, line up your cut, switch on, and slowly feed the saw towards yourself with a stiff wrist and elbow. As you can see, the upper face is perfect, unsplintered and shattered, and all the tearing is on the back face where it doesn't matter at all. As you'll probably realise, in a climb cut, the saw blade is cutting down onto the work and holding the work firmly against the table, rather than a feed cut where there is some tendency for the work to lift off the table. Now, you can use that to good advantage when cutting thin, flimsy pieces of moulding or quad or whatever, picture frame material. Use the blade to hold the work down on the table. Mind you, of course, you can always cut those pieces in a table saw mode, but if they're very long and awkward and you happen to be in the cross-cut mode, you can do it as a climb cut. The 45-degree mitre cut, one of the most common cuts used in woodworking and certainly one of the most troublesome. There are many ways of cutting mitres, and the table saw mode is generally the first mode you should consider for cutting mitres. You'll see a bit more on that later on in this video. However, if you're cutting long pieces of moulding or architrave or cornice, then obviously you'll want to do it in the cross-cut mode where you don't have to move the wood, you can move the saw. Now, the Triton makes mitering very easy because you've got this excellent protractor which has two faces which are exactly at 90 degrees to each other, and you'll see how valuable that is shortly. Talking about these faces, they are lined with sandpaper. This is so your workpiece won't slip on the painted surface as you're doing the cut, because there is a significant tendency for the wood to creep along the face of the mitre gauge. That's why the sandpaper's there, and will generally eliminate the need to use G-clamps to hold the work to the table or to the mitre fence. The sandpaper should provide enough grip. Now, you can lock the protractor anywhere that you like in this slot in the table, especially if you remove the two work stops. You can lock it where you like to admit any width of timber that you want to cut. Let's just lock it off here, loosen the large T-knob, push it down, turn the locking head around and lock it in position. And then if you wish, you can fine-tune your angle setting, but this is set at 45 degrees, so let's do a test cut and see if it's right. Get yourself a piece of scrap and position it in the work centre so that you're creating quite a substantial offcut. You may want to trim that offcut again later on if the angle setting isn't quite right, so make it big enough so that you can hold that offcut and do a cut on it later. Hold the wood firmly against the sandpaper face, do a smooth, even cut. Don't push the saw in too fast, it's critical on a mitre cut. So just do a cut at 45 degrees. Clean any fibres off the pieces and lay them down on a flat surface, and just check firstly, sorry, there's a tiny little dag there, just check firstly that there is no gaping at that point. If you've got a chink of light showing through there, then obviously your saw blade angle is incorrect in relation to the table. Either you need to adjust your wing nut on the front of the saw or adjust your table slightly. But if that matches up perfectly, then you can turn your attention to the joint itself, and with this sitting touching neatly, I can take a tri-square and take a reading and see how it fits. Well, that's absolutely perfect. I hope you can see that. But that's an absolutely perfect 45-degree miter joint, because it's touching all the way along the joint and there's no light showing between the wood and the tri-square. If that wasn't quite correct, then you'll have to make a very slight adjustment in the setting of the miter gauge by loosening this knob here, the front one, and making a tiny adjustment setting. And I say tiny because what you've got here is an offcut being placed against the main piece. So if the gauge was set in error at, say, 44 3/4 degrees, a quarter of a degree off, you're doubling that error, because both of these pieces are 44 3/4. Twice 44 3/4 is 89.5. A quarter of a degree of setting error will result in a half a degree of cutting error. So make minute adjustments, and because you've left both of these pieces long enough to comfortably handle, after each adjustment, do a shaving cut on both pieces to make sure they're going to be, you're treating them the same way. The two faces of the gauge are at exactly 90 degrees to each other. They're perfectly square. So let's just set this up here. And let's imagine for a moment that we have an error, and let's introduce an error of 1 degree in the setting. I've deliberately set this now at 44 degrees. I'll put one piece in here and cut it. Just take a shaving cut off at 44. And I'll put my other piece against this face. Now, if that's 44, that must be 46, because they both add up to 90 exactly. Holding it even more firmly, because now I'm pressing it, pulling it back towards myself. Thumb hooked over the miter gauge, hold it firmly, again, just a shaving cut. And we can virtually guarantee you that any pieces cut, where one piece is cut on face A and one piece is cut on face B, they will always add up to a perfect 90-degree right angle. Guaranteed. You'll find it's very useful to attach wooden fence extenders to your miter gauge, and we of course provide the holes to enable you to do that. Now, when you're cutting a frame, say a rectangular frame or a square frame, it's very important to have all the opposite pieces exactly the same length. Instead of measuring and marking each piece and therefore running a risk of an error, and then trying to cut exactly to the line each time, another chance of an error, it's best to use a wooden fence extenders and a stop block. Stop block just like this, miter cut on one end and cross cut on the other end. Now, important little point. This is too small to cut and hold. Obviously, your fingers would be too close to the blade. How do you do it? Well, cut a 45-degree miter on a longer piece and then trim off the end, the waste piece, which you now want. The offcut becomes your clamping block, which you can then clamp to the stub fence. Make sure it's nice and square. Clamp it on like so. Adjust it if necessary. Then you take all of your long pieces, cut the first cut on face A of the protractor, like so. Again, try to set face A at 45 degrees as close as you can, but it's not essential that you be spot on. Having cut face A, you can butt the piece you just cut into the stop block and then cut face B. Remove the offcut when the blade stops spinning, pull the saw back, and there you have the complementary reverse angle, and every piece cut in this way against that stop will be exactly the same length. Just before leaving miter cutting for the moment, there's a couple of joints I'd like to show you. Firstly, the halved crossover joint. Very strong and very useful if you're building gates or fences or verandas, for example. What you have to do is cut your pieces to length and cut them so they fit into the frame you're building. Then mark them in position, pencil mark there and there, and on the back of the other piece there and there, and then you can put the two pieces into the work centre with the pencil marks lined up exactly. And here's another hint too: if you're working with very long, heavy pieces, then don't try to rest them against the Triton's protractor. It's not quite long enough. Use the protractor to set a straight piece of wood at the required angle, normally 45 degrees. Either clamp the wood to the table in the correct position or screw it to the protractor, and then with your blade raised for a half cut only, you can make a series of cuts through there, moving the wood sideways after each cut. Again, it'll help you if you tape the pieces together. The half-lap mitre joint, an extremely attractive joint because it's mitered from the front, and yet it's also very strong because the two pieces are halved in together. Here's how it's done. Beware, the two halves of each joint are not the same, so don't fall into the trap of making them all the same. Take one piece of each joint and raise the saw blade so it's just cutting halfway through the work, and then with the piece resting against face A of the mitre gauge, face A is set exactly at 45 degrees to the saw blade, make a series of cuts, removing the waste, like so, of this small triangular piece here. Then take the other piece of each joint and place it against a work stop, square to the blade, again with the blade raised for a half cut, make a series of cuts until you've removed half of the piece of wood to the end, and then all you have to do is set the blade down to its full depth of cut, and with the wood against the mitre gauge, remove the small triangle of halved material still connecting. A bevel cut is where you angle the saw blade to the table, and it means you can achieve an angled cut across a wide piece of wood, 18 inches, 450 millimetres, or even wider if you've got a smaller saw. Here's how you do it. Before disturbing your carefully found zero position on your power saw, take a scriber and make a scratch mark on a part of the saw to show you where true zero is, because you'll need to find that position again when you go back to normal cross-cutting. Having found true zero, loosen off the saw blade adjusting mechanism and raise the blade very slightly. Just lift the teeth out of the saw blade slot, otherwise they'll kiss against the edge of the slot, and set the saw at what the saw says is 45 degrees and lock it in position there with the blade now fully lowered. You may find, depending on the saw you have, that this safety guard will flip open at this point, so simply take a piece of tape and tape it in position. Okay, now you'll find, having done that, that the saw blade no longer reaches the table because it comes up in an arc out of the slot. Do not raise your table. Guaranteed recipe for disaster. Rather, put some packing on the table underneath the workpiece to offer the workpiece up to the blade. The amount of packing you'll need will depend on the power saw you're using. In this case, a piece of 19mm particle board isn't quite enough, so I'll put a piece of hardboard underneath that again, and that should raise me up high enough. Bear in mind you will be cutting into this board. It's a sacrificial board. Then put your workpiece in. Just check that your saw teeth actually turn around. The saw blade turns around when you're running onto the sacrificial board. That feels fine. Now you can put your workpiece in position and do the cut shortly. Another thing you should check too, when you're at 45 degrees or your selected angle, do a complete dummy run and make absolutely certain that your saw blade can't hit the notched workstop. This notch in the left-hand workstop is to admit the saw blade when it's angled. Now most saw blades will sail through that notch at 45 degrees, but at shallower angles you should always check to make sure the saw blade is not going to hit metal. That's why you do the dummy run. One important point though, a bevel cut will put an enormous amount of load on the power saw itself. The saw's got enough to cope with without you twisting the hand grip of the saw as you do the cut. So here it's very important to switch off the power, lock the trigger of the saw on, make sure everything's nice and tight, the saw's fully clamped down, wing nuts, everything tight, and then you can do the cut holding the wood quite firmly, because there is a tendency for the wood to move sideways during this cut. So hold it firmly or consider clamping it in position. Use a locked on trigger technique and switch on and make the cut. Now, if you didn't move that sacrificial board, you'll find you've now got a score line in it, and that was made by the tips of the blade teeth. If you were to clamp that board in position now, then you'd find that the saw blade will always pass through that line and give you an excellent sighting point for future cuts. The piece of particle board which I just cut is very free cutting material. Now get yourself something a little bit harder, softwood will still do, and get a couple of fairly lengthy pieces long enough to hold comfortably. Now, a bevel cut puts an enormous amount of load on the power saw, so you must have a sharp blade and don't feed too quickly. Also, because of the incredible load on the saw, we do strongly recommend the locked-on trigger technique is used, so switch off the power and lock the saw trigger on, because almost certainly in pushing the saw you would twist it slightly if you held onto the hand grip. Also, there is a tendency for the wood to move, so hold the wood down firmly, or perhaps even consider clamping at the table. Another option is to put a sandpaper face on the work stops to hold the wood more firmly. You'll see a bit more on that in a few moments. Hold the wood firmly, hold the two pieces together, lock your fingers around them, position the saw, line it up. You've already done a dummy run to make sure you can't cut through the metal work stops, and then position it, switch on the power and make your cut. If on a bevel cut you get a bit of a burn mark on the wood or a slight step, which I haven't got here because I've got a nice sharp blade, but if you do get some ridging or a burn mark or a step, it's very, very simple to just make your cut, pull the saw back, clear the offcuts from the table, and then inch the wood very slightly that way towards the saw blade, very slightly, and make a shaving cut, just a finishing cut like this. I'll just show you, even though I haven't got a burn mark to get rid of, I'll just show you the principle of a finishing cut. As you can see, I'm removing less than one blade thickness. Now, the less you can remove with a skimming cut, the better, because obviously if that blade cuts 3 millimeters on a normal cut, if you're only taking 1 millimeter off, then the blade's working 1/3 as hard as it was previously, blade and saw and so on. So do shaving cuts to get a perfectly smooth, perfect bevel. Once you've done your finishing cuts and you're happy with them, then you can arrange the pieces. You can actually use the aluminium bearing channels of the Triton and the workstop to give you a right angle, and check that they're exactly square, touching all the way when they're in a right angle, or use a normal tri-square. Once you're happy with your true 45 position, take your scriber again and make yourself a little mark at true 45 for future reference on your saw. Alternatively, you saw earlier how we recommended that you make this saw blade height setting block with a couple of rulers on it. Well, the same block could just as easily have a bevel cut side, so you can use that sitting in here against the workstops and use that as a setting block to get your saw blade angle absolutely correct. You will have noticed during your experimental bevel cuts that it's very difficult to sight up exactly where you're going to cut. Well, there's an easy way around that problem too. And that is to make up a permanent little bevel ripping platform like this. It's basically a piece of particle board, and because of the saw I'm using, I've had to put some masonite as well, or hardboard underneath that as well. It's got two cleats there and there. Now they are spaced so that this sits snugly on the Triton table, and that's very important. You'll see in a moment why. And finally, it's got a vertical fence to rest your work against, and that's got sandpaper glued on it to stop the wood creeping during the cut. This is how it works. You slide this on like so. It drops on, and the cleats make it impossible for this to move sideways. It's now firmly on the Triton table. Okay, the very first cut you make, you'll make a score line along here and a 45-degree cut through there. So make sure before you do this that your saw is cutting exactly 45 degrees. You can either mark your desired distance on the bevel, like so, or you can just put a tiny little mark on the end on the wide face of the material, because you can use either or both of the notches, whichever you prefer. This is how you line up on the bevel, by just touching the pencil line to the edge of the score mark, or if you want to use a notch in the fence there, that's how you line it up, and you'll cut exactly to your line each time. Bevel cuts are most commonly used for making square or rectangular frames. Now with a square frame you want all 4 pieces to be exactly the same length. With a rectangular frame you want the top and the bottom the same length and the 2 sides the same length. Okay, the idea is don't measure and mark each piece separately, cut them simultaneously. Very simply, trim all the ends of your pieces to length, get a nice bevel cut on them, do a shaving cut if necessary, then turn the pieces around, get the bevel cut ends dead in line, run your finger along them, 2 or 4 pieces simultaneously, then move both of them in together, like so, tape together if you wish, and then make a cut, and those 2 pieces will be exactly the same length, or 4 pieces if that's what you're doing. A 45-degree bevel joint, while it's very attractive, isn't terribly strong. You've basically just got the glue to hold that from opening up. Now, you can, of course, dowel that joint, but that's quite a tricky operation. There is a simpler way, and that's to cut a spline groove or a keyway. And you do that very simply like this, cutting the groove with the 2 pieces in the open position, and then cutting a piece of plywood, contrasting colour or the same colour, to fit in there and lock that joint together beautifully. And that, of course, gives you much greater gluing area, and because the piece of plywood, the tongue, is in tension, it makes it very, very strong. Just a quick point about spline grooves before I show you how to make them. While it's desirable, I guess, for aesthetic reasons, to have the groove central on the bevel, it's not essential. As you can see from this example, that keyway is well closer to this corner than it is to there. But as long as you do the 2 pieces together, they'll always match up perfectly. Here's how. Again, do your pieces 2 at a time, and perhaps mark the halfway point on the bevel on one of the pieces with a pen or a pencil. Place it into the work centre, line up the pencil mark you've made with the 45-degree sighting notch. There you go, lined up central in the notch. Line the 2 pieces up together. Now here's a very important step. Raise the saw blade, otherwise you'll cut all the way through your beautifully cut bevel. So raise your saw blade. You don't have to raise it very far, but raise it a fraction. Again, trial and error is a good idea here. Hold the pieces firmly. You may have to clamp them in position, but you should be able to hold them, especially if you've got sandpaper on the face of your fence. Switch on and make a cut. And because those 2 pieces were cut simultaneously, then they must add up to a perfect slot when you put them together. If you don't want to use plywood for the key or the tongue, then later on in the table saw mode we'll show you how you can rip yourself a narrow strip of the same sort of material so that you can make a concealed spline bevel joint. There will be some occasions, for example when you're building a hip roof, where you need to cut a compound miter, also known as a bevel miter or a compound cut or a creeper cut. And that's where you're angling the wood and you're angling the saw blade simultaneously to get this splayed effect. To cut the bevel miter, remove both of your work stops, lock the miter gauge in its slot and determine the angle you want to cut at. In this case I've chosen 22.5 degrees. Then adjust your saw blade angle to the other angle that you want on the compound cut, also 22.5 degrees in this case. Then put a piece of packing, sacrificial board down on your tabletop, because you will be cutting into that board and you certainly don't want to cut into your tabletop. Put it down and clamp it in position to the table. I'll explain the clamp in a moment. Hold the piece of wood firmly against the sandpaper face of the miter gauge and make the cut. There's the bevel miter. Now, the reason for the G-clamp holding that sacrificial board in the spot is that that score line there is where your blade passes. So in future, when you want to cut to a pencil mark, you simply mark your piece of wood where you want to cut it, place it right above the little score line, and away you go, you can cut accurately to that mark. You can get some really spectacular results on a piece of straight wood by making a series of evenly spaced cuts in it, so that you can then bend the piece of wood into a perfect right angle or an arch, as in the case here. Now, it's called kerfing, and it derives its name from the fact that each of those cuts is called a kerf, the saw kerf. Before I show you how it's done, a few principles. Firstly, for this to be neat, each of the cuts has to be equally spaced, the same distance apart from the other. That's quite easy to achieve. But now have a close look and you'll notice that the bottom piece, the cuts are further apart than they are on the top piece. As a result, the top piece bends into a very tight little radius, and this piece, where the cuts are further apart, is a much more gentle radius. So the distance apart controls the tightness of radius of the bend. Another principle is that for a given saw blade, if you don't change your saw blade and you don't change the thickness of material you're cutting, then the same number of cuts will give you a right angle no matter how far or close together they are apart. For example, if this is 1.5 inch thick material, then 14 cuts with this saw blade will give me a perfect right angle. If they're very close together or very far apart, they'll still give me a perfect right angle. And you'll have to do some trial and error experimentation to get that into a perfect right angle. A little hint, a cheating hint if you will, is that if you find that 14 cuts gives you a little bit less than a right angle and 15 gives you more than a right angle, what you can do is effectively have 14.5 cuts. How do you do that? Well, you cheat. The first and last cut, make them very slightly wider. Do a cut and then a shaving cut, a cut and a shaving cut, and you've basically then got 14.5 cuts without it looking obvious. You can, by taking it even further, if 14 cuts give you a right angle, then 4 times 14 will give you 360 degrees, or twice 14 will give you 180 degrees. So you can experiment with kerfing and make any shape or size you want, provided it's curved. The next question you have to address is how much material to leave uncut. Now this is very much a matter for trial and error. Leave too much uncut and it'll break as you bend it. Leave too little uncut and you won't have terribly much strength in the curve. So you have to play around with that, and it does depend very much on the moisture content of the material, but I'll talk further about material later. Trial and error would suggest that anywhere between 2 and 4 millimeters of uncut material is what you should allow, and so raise your saw blade the appropriate amount, and always with kerfing, always test on some scrap, because there's nothing more frustrating than to have selected a perfect length of material for a job and then find that you've done all the kerfing and then it breaks when you're actually bending it into shape. So, take an offcut of the material you'll be using, raise the saw blade by an arbitrary amount. I'll just look down here and raise it by, say, 2 millimeters or so. Now, here it's very important to use a locked-on trigger technique, because you can move the saw up and down very slightly if you push a little heavily on the saw hand trigger. So switch off the power and lock on the trigger. Now select an offcut where at least one face, the face which is going to do the bending, is free of imperfections and has long straight grain, and have that good face downwards. Put it in the machine. It's also essential that you have 2 work packers on the work stops, and I've made a pencil mark on this one a short distance away from my sighting notch. Now that pencil mark, the distance between that and the notch, will give me my spacing. Of course, you can change that by rubbing out the pencil mark and putting a new one on wherever you want it. Basically, what you do is you make a cut wherever you like, say about halfway across the piece, with the saw blade raised. Lock the trigger on. I've just stopped at 14 cuts there. Well, it's clearly not enough. That's not a right angle. Another couple of cuts and I'll be right. Put it back in, line up the last cut you just made with the pencil mark, and then make the next cut, and so on. Just keep lining up the cut you've just made with the pencil mark, and that gives you perfectly even spacing. As you can see, I've cut this piece almost all the way through, and there's very little material left, so it's very easy to bend this one. It's also not that strong, but if you leave a thicker amount connecting, then take a good deal of care in bending it. In fact, flex it a little way and leave it sit there. Tie it in position if you wish. Bend it a bit more, tie it in that new position. Bend it a bit more and tie it in the final position. Give the wood fibres a chance to accustom themselves to their new configuration, their new shape. If you've left quite a bit of material connecting, then you may want to experiment by getting the kettle out in the workshop and playing some steam on the face which is going to be bending. You can also try some hot water on that face, but do not immerse the whole thing in water because it'll all swell up and you'll ruin the piece. These two examples of kerfing show dramatically the difference in radius with the different spacing of cuts. But I mentioned a moment ago the idea of tying the wood into position so that the wood fibres can get a chance to accustom themselves to the new shape. Well, you can tie it, or you can make up on a piece of particle board some little blocks or corners, or use L-shaped corner block pieces like this to lock your curved piece into its new position, or in stages getting up to its new position, and leave it there to get used to the new spot, or in fact for the glue to dry. Now, when it comes to gluing it, you can just glue the inside of each curved piece and allow the glue to hold on the very corners there, the very edges, and that's reasonably strong. If you want some real strength in it, then you've got to put some filler in. You can mix up your own filler using sawdust and PVA glue, clear colourless glue, or indeed you can use a tinted filler, black or red or brown or whatever colour you need. Car body filler can be used quite effectively, and even some construction adhesives like liquid nails, for example, they can be used quite effectively for gluing up and getting a lot of strength back into kerfing. Well, you may be excused for wondering just what you use kerfing for. A number of uses, surprisingly. Firstly, you can use it for decorative effect. If you'd built a bar and you had these all along the front of it, nicely stained and glued on, they'd look very unusual and unique. Secondly, if you make it strongly enough, you can use kerfing for a banister, a handrail for a set of stairs, for example. You'd have fewer cuts so that this part rises at the angle of your staircase. That's one use for kerfing. Or you could make an armchair where that's your armrest and that becomes your leg. Very interesting application. One thing I've just recently made is this coffee table, all fully curved with a glass top, smoky glass top. And as you can see, it's curved for the top and the legs are also curved. So the limit is your own ingenuity. Play around with it. You'll get a lot of satisfaction out of kerfing and a lot of frustration. You'll break a few pieces, but persist with it, be patient, and you can get some really amazing results which your neighbours and friends just won't believe that you have done. There are a number of materials which are suitable, and you can even kerf hardwood. Don't be afraid to try it on hardwood, as long as the moisture content is fairly high. Avoid material that's been sitting in a dry, air-conditioned or heated environment, preferably something that's been stored outdoors in an area where there's quite a lot of moisture content in the air. Now, materials you can try in Australia include things like silver ash, myrtle beech, spotted gum, celery top pine, king billy pine. They all work very well. If you can't get hold of any of these materials, consult your local timber merchant. He may be able to help you. But definitely look for material which is long and straight-grained and has very few defects or imperfections. Good luck. All of the cuts you've seen so far have been made in the cross-cut mode. And as you know, there are several other modes of operation of the Triton Workcentre. And I'm about to show you how to do a conversion from the cross-cut mode to table saw mode. It only takes about 30 seconds. And we'd really like to encourage you to use the different modes whenever appropriate. Rather than struggling in the inappropriate mode, it may be much easier just to change the machine over. It's as easy as this. Switch off the power. Lock the trigger of the saw on. Fit the trigger strap. Then slide the saw towards the rear panel and lift two of the bearings up out of the bearing channels. Then your blade is out of the slot in the table. You can unlock the two locking keys, pull the table forwards and out sideways, and just rest it down on the floor there. Then disconnect the power and reroute it through here. And now you can complete your inversion of the saw, turn it upside down. You may have to blow sawdust out of the channels, there you go, and centralise your saw with the marks you've made. Turn the table around, put it back on top, and that should neatly lock in position, and you put the keys into the holes labelled R. Then you can remove the work stops. Always double check that the saw chassis is firmly locked by the tab underneath the table, and then fit the safety guard and riving knife as close as you can behind the blade, about a ½ inch or 12 millimeters behind the blade, and lock that in position. Now the rip fence. It goes in here, the high side of the fence closest to the blade. Drop it in, turn the feet through 90 degrees, and almost lock them up. Still free to adjust and slide, but easy to tighten. And then the miter gauge fits in this slot, and you're ready to go as a table saw. When converting back from the table saw mode to the crosscut mode, there's a couple of very important points to consider. Firstly, clear off the table and remove the table and put it to one side. Then pull the saw towards yourself and flip it over like so. That way you don't tangle in the power cord. Rest those two bearings on top of the channels for the moment. Turn the table around so the T-shaped holes are closest to the rear panel, and then slide the table into position and lock it in. Now, two important points. Firstly, don't forget to put these bearings back in their channels. Otherwise, when you finish a cut, you drop down and perhaps damage your blade and damage your Triton table. Now the other point is the power cord. As you can see, by converting this way, the power cord is now between the channel and the table, and that eliminates the need for unplugging and replugging, and you may be tempted to do it this way. However, there's a problem. The power cord can become snagged in that corner there, and could either impede your cut or, under certain circumstances, could back up on the table like so, and you might conceivably recut the power cord with a spinning saw blade. So it is best to unplug and route the power cord out beyond the front of the machine and into the plug. The table saw is probably the most versatile and useful piece of equipment you're ever likely to use in your workshop. However, it's also the piece of equipment that probably causes the most number of accidents and injuries of any, perhaps because of its wider use, or perhaps because the saw blade is exposed and people become complacent and end up hurting themselves. Now, you can use a table saw very, very safely if you follow some rules and follow them all the time. Firstly, always keep your fingers clear of the blade. Take your piece of wood and rehearse the cut. Determine where your fingers are going to pass, and make sure you've always got the safety guard fitted and lowered so that only the wood can pass through. Now, when you're through ripping, when you're ripping all the way through a piece of wood, you must have the riving knife fitted and the safety guard. Must be on every time you're cutting all the way through. There are certain other cuts where you don't have to have the riving knife and safety guard, but we'll get to those later. For through ripping, always have them on. Never reach behind or over a spinning saw blade. That's a very large cause of accidents. People do the cut quite effortlessly and then carelessly reach beside or behind the blade to clear a scrap off the table. Don't. Have a stick handy and use that to flick the scraps off the table, or switch off the power, wait till the blade stops spinning, and then take the scraps and remove them from the tabletop. Whenever you're ripping a piece of wood, and especially when there's a narrow piece between the blade and the fence, always use a push stick to push that wood through behind the back of the blade. Just remember one thing: wood grows again, fingers don't. We'll show you later on in this video some other jigs and fixtures and push sticks which will make your work easy and safe. Never attempt a freehand rip. By that I mean, don't ever try to rip to a pencil line just feeding the wood through by hand. You must use the fence or the protractor to guide the workpiece past the blade. Because look what would happen if you were doing a feed cut by hand following a pencil line. If the wood skewed only slightly, it would jam on the blade and the blade would kick the wood back towards you at a terrifying rate and possibly cause an accident. So, always use a fence or the protractor to guide the work. Talking about the fence must always be set absolutely parallel to the saw blade. You can rip tapers on the Triton. You certainly don't do it by angling the fence in towards the blade. That's an extremely dangerous situation. Bear in mind at all times when you're setting the fence, the reading in both windows must be the same. And as a very important point, if you've set the front window first, and then you've set the rear window to suit, always go back and check the front window again. You'll find it's probably moved very slightly in setting the back. So, lock it off exactly parallel, and then you can feed your work through. Having said that, you may find some circumstances where you'll want to have a slightly higher reading in the rear window than in the front. And I mean slightly, no more than 1 millimetre or a little over a 32nd of an inch. And you can give yourself some relief or escape at the back, and you do that when you're cutting green timber, which tends to bind on the saw blade, or very badly dressed material, or if for any other reason you find the workpiece is jamming very slightly between the fence and the riving knife. You can give yourself about 1 millimetre of escape in setting the fence. Otherwise, absolutely parallel front and rear. One last point about fence setting: every time you've set the fence to a new position, double check that it's properly locked at both ends. Make sure the fence is securely locked down. Never feed from the back of the blade. The riving knife normally prevents you from doing that anyway, but the sort of people who attempt to rip from the back of the blade often don't use the riving knife. So, let me show you what happens if you are foolish enough to attempt this. The saw blade is spinning around that way. If you feed onto the back of the blade will lift the wood and rip it out of your hands at an incredible rate and could cause serious injury. So never feed from the back of the blade. You must always feed from the front of the blade so the teeth are cutting down onto the wood, pressing the wood firmly against the table. Never switch on the power to your saw while there is anything touching the blade, like a piece of wood, and never switch on the saw when there's a danger of something lying on the table, a scrap or a tri-square or a pencil vibrating in towards the blade. If during the course of a cut you run into a problem, do not pull the workpiece out with the blade still spinning. This is what you do. Wait until the blade stops spinning, and then when it's come to a complete halt, you can pull the workpiece out. Let's say you've got a piece of wood like this, and you want to rip this much off it. Now you've got two choices, of course. You can set the fence in very close to the blade, like so, and take off this narrow strip, the narrow strip ending up between the blade and the fence. But that is the wrong way of doing it, for the reason just mentioned a little while ago, that you'll have a narrow, thin, spear-like piece trapped between the spinning blade and the fence, and of course as soon as you finish that cut, as soon as you get to this point here, that small piece will go spearing out backwards very quickly. For that reason also, get into the habit now of never standing directly in line with the blade. Always stand to one side or the other. But more importantly, avoid situations where you're going to have a narrow off-cut trapped between the blade and the fence. Do it this way. Turn the wood around, set the fence to the wider dimension, and have the narrow piece fall harmlessly aside on this side of the blade. I've set the fence at the wide dimension so that the wider part of the piece is going to be between the blade and the fence. There's plenty of room in there for my fingers to get through so I can keep good hand control. I don't have to use a push stick. Hands are better than a push stick. You get better control when it's safe to do so. I'm going to keep my fingers very well tucked in, no fingers trailing at the back end. That's a very common cause of injury, fingers trailing behind there. I've already checked that this is a nice straight face that I'm running against the fence. It's very important that the face which runs against the fence is straight. The blade is square to the table, the safety guard is fitted and lowered so the wood can just pass through. Ready to go. Switch on. You'll notice I continued pushing the piece of wood until it was well clear of the blade, and then when the blade was slowing down, you can easily pick up the offcut and put it aside. Now let's just check that cut. Always work from the face which was resting on the Triton table and check it with a square all the way along. Now I can see intermittently little chinks of light showing through there. It is very difficult to get a perfect rip cut first time. A few tips coming up on that. But one of the important reasons that I've wandered off square in this is that, can you see how this piece of wood is twisted? Wood is very rarely straight, and of course the cut will reflect whatever twist there is in the piece of wood. So obviously try to select a straight material as you can, because it will affect the quality of your cuts. There are several other ways of achieving the same result though. Firstly, work with the appropriate saw blade. Now I've changed from the cross-cutting blade, which had 60 teeth, to a coarser ripsaw blade. Now the coarser blade gives you a higher feed rate, if you wish, because the teeth, the gullets behind each teeth, can cope with the amount of sawdust being created. A finer tooth blade can be used in a table saw mode, but of course you have to feed the wood a little more slowly. So you'll have to experiment with your feed rate to make sure that it is appropriate for the blade you've got fitted. Feeding the wood too slowly can be bad as well, because you might burn it. So you just have to experiment and get the right feel for it. I can't really tell you how to do it. You've got to find it out for yourself. But a few things that you can learn now. Work with a lowered saw blade. Now in this piece of 4x2, the saw blade's only just cutting through it. But imagine I was cutting a thin, narrow piece like this. Okay. The best way of doing that is to lower the saw blade until the blade teeth are just showing through the material. That's not only safer, of course, the less blade that's visible, the less chance there is of an accident, but also gives you a much smoother cut with less ridging and splintering, because the angle of approach of the teeth is much shallower than if they're cutting down from directly above. So lower the saw blade until the teeth are just protruding above the material being cut. Secondly, don't pause or stop during a cut if you can help it. Keep going in one smooth, uninterrupted motion. Every time you pause or stop, you'll get a very slight step in the cut. Avoid that if possible. Thirdly, do a finishing cut if you can. In other words, let's say you wanted this piece to be 70 millimeters wide when you're finished. Well, rip it to 71 mil first, then set your fence in at exactly 70 and do a finishing cut. Very much like the shaving cuts that you were doing in the cross-cut mode. Just reset the fence, say a millimeter, always double check the back setting, say a millimeter narrower than it was previously, and just do a shaving cut like this. Whoops, blade has to come back up again. Now, if in that finishing cut I was taking 1 millimeter off and my saw blade normally cuts 3 millimeters, then the blade and the saw are only working 1/3 as hard as they were previously, and the finished result should be much smoother, squarer, and generally a better rip cut. When you're ripping a very long piece of wood, you must be mindful of the fact that you need good support before, during, and after the cut. Let me show you what would happen if you tried to rip a long piece of pine like this without good tail-out support especially. Lead-in support you can normally manage by supporting the piece of wood like this, with one hand back and one forward, but tail-out is a problem. See, as I feed this through, progressively, as the cut end hangs over the end of the machine, it becomes more and more difficult for me to support this piece, and eventually it starts lifting, jamming against the saw blade, putting me in a very dangerous position where I'm leaning and I could easily overbalance and the wood will drop like that. So always have tail-out support, that is if you can't have a friend to help you. If you are working on your own and you want to rip a long piece down, then there's a couple of ways you can do it. Firstly, the best way is to have the Triton extension table and then as you feed the piece of wood through, you've got something to catch it at the other end, and you can continue through with no problems. If you don't have the Triton extension table, you may recall the trestle we made up in the crosscut mode to support long beams. Well, it's just as useful in the table saw mode for supporting a long piece being ripped. And of course, you just simply feed the material through, and the trestle acts as a catcher for you to support the long, heavy offcut. If you haven't got the Triton extension table and you can't be bothered building the trestle and you don't have a friend to help you, you can still cope with long beams, but this is not really recommended. I'll show you how to do it. It'll involve starting off the cut working from the front of the machine, then towards the end of the cut walking around towards the back of the machine and pulling the work through. You will probably end up with a step in the cut, but at least you'll have done the cut. Very importantly, when you pull the work through, do not jam the two pieces together. They could bind on the back of the blade and cause further problems. So just grab the main piece that you're pushing through, as you'll see. It is important when doing this cut to try to keep the material moving at a steady rate all the way through. Pauses and stops will give you a step in the cut, but in this time I got off lucky and it's quite a smooth cut. Let's say you've got a piece of wood and you want to rip a very, very narrow strip off it, perhaps a strip of veneer, or perhaps a key for one of those blind bevel joints you saw in the crosscut mode section. Well, don't fall into the trap of moving the fence in close to the blade, say 2 millimeters away from the blade, and trying to rip a narrow strip there. As mentioned several times, that will come flying out and will get badly damaged by the spinning saw blade. Rather, set the fence to the wide dimension and have your little 2 or 3 millimeter piece on the outside of the blade. Now, that's normally a bit dangerous because that narrow strip can easily fall down the slot in the table between the blade and the edge of the table and can jam in there. It'll certainly get damaged, and it could even damage your saw or blade. So here's a very simple way of coping with that problem very safely. You'll see that as I'm about to finish the cut, I'll bump off the power with my knee and let the blade stop spinning. Now I can safely withdraw the piece and simply break off my very thin strip of veneer. If at all possible, when you're ripping narrow pieces or awkward pieces, try to use a wooden jig of some sort to hold and control the wood. The simplest form, of course, if you wanted to rip a piece like this in half, is to hold it with a piece of scrap, just any piece of scrap material, and apply the pressure in front of the saw blade, not beside the saw blade. Never pinch the wood against the blade. Apply the pressure directly in front of the blade. You may want to rest 2 fingers of your left hand over the top of the wood to hold it down, and prepare a push stick. Now, the push stick should be narrow enough to be able to fit between the blade and the fence, like that. And very simply switch on. You'll notice the tendency of the wood to flutter up the blade. Now that will happen with light pieces of wood, and there's a very simple way of rectifying it, as you'll see in a moment. A somewhat more sophisticated push stick is like this. It has a right-angled notch at one end and another one at the other end. This is for thicker material, that's for thinner material. And very simply, you hold the notch over the edge of the material and push it through. If you're dealing with a piece of ply, for example, and it does have a very marked tendency to flutter up the back of the saw blade, then you really need to apply holding down pressure further forward than the back of the piece. In fact, you'd like to ideally hold down right beside the saw blade. Well, this sort of push stick will help you do that. Hand grip, there's a notch for conventional usage. Right? You can use it for a wide piece by using that notch there. But for cutting a piece of ply, for example, you've got a long flat bottom and a little heel there. And of course, that hooks over the back of the ply and applies downwards pressure at this point beside the saw blade, and you can cut it without running the risk of flutter. Another very useful jig is what we call the hold down jig. And very simply, it forms a tunnel between the rip fence, like so. It's adjustable for any width of material. And there's a stop block here to hold the work down onto the table. So you're actually captivating the wood and it can't move anywhere. Just before doing this cut, there's a very interesting point. Have a look at this small offcut that's going to be created. Now that is narrow enough to fall down between the blade and the slot in the table, and that's a very dangerous situation. I'll be able to do it in this instance because of two things. Firstly, I'm using the riving knife, and that fills in the slot behind the saw blade. And secondly, the piece of wood is long enough so that by the time I finish the cut, most of it is well behind the danger area being right there, and so there's no problem in doing it. If I was working on a smaller piece, you'll see a little later in this video how to cope with that problem of an offcut falling down the slot. But very simply, set up your jig like so, use a push stick, and away you go. Let's say you've got a board and you want to rip it into a number of identical strips, narrow strips especially. So you can make up this repetition ripping jig. This is actually a dual purpose jig. It's also a taper ripping jig, so for the moment I'll ask you to ignore some of its features. Get yourself a fairly wide, chunky piece of wood, wide across the base so that it's got plenty of support on the Triton table itself. Make a cut in it to accept the high side of the rip fence. Cut the bottom of this piece off so you clear that radius in there. Now, a small warning, don't make this section too wide, too thick, because you'll have trouble clearing the knobs. Now, at this end of the jig, we have a push handle. Please ignore this part for the moment. And a stop block. Now, that stop block has got a slight angle on it so that it will tend to hold the work down as you're passing the saw blade, prevent it from climbing up the saw blade. And then all you do is put your wood in the jig against the stop, switch on and make your cuts. And this way, you're controlling the piece between the blade and the fence, keeping it under control. It'll suffer no recut damage at all, and every piece cut this way will be exactly the same width. You may find there are instances where the piece of wood you want to cut is too wide to be cut in a single pass by the saw blade. Your blade just won't reach through. Well, that's not really a problem because you can do a double cut, and the amount of blade protruding above the table can effectively be doubled. What you have to do, though, because you'll probably be working with a piece of wood standing tall on edge, you'll need to attach a high fence extender to your rip fence and screw that onto the rip fence and make absolutely sure that it's nice and square at the table. If it's not square, you can put some packing, thin business cards or sheet metal or plastic, between the back of the fence and the rip fence and get that nice and square. Similarly, check that the saw blade is dead square at the table, because you're doing a double cut and any error between the blade and the table will be doubled. Now, because I'm not cutting all the way through this workpiece, I cannot fit the riving knife and safety guard, so I'll take a few precautions. Firstly, I won't trail my fingers behind the workpiece, guaranteed source of an injury. Now, I need to take some precautions to hold this workpiece firmly against the fence. Probably the best way is to use this hold down jig you saw earlier, lowered until it's holding the workpiece against the fence and down on the table. Alternatively, use another piece of scrap, something fairly tall, to form a tunnel there. Then you can push the workpiece through, and for additional safety I'll be using this push stick which you saw earlier and pushing the work through. Here's how it's done. That actually felt a little bit tight as I finished the cut. I think I'm binding very slightly on the back of the blade, so I'll just give myself a whisker of escape, just about 1/2 millimetre in the rear fence setting. Then turn the wood end for end. Don't turn around, just end for end, and your two cuts should line up perfectly. Again, put the scrap in. But now I'll be separating the two pieces, so I can use the riving knife, if not the safety guard, at least the riving knife, to help keep the two pieces separate as I cut through them. So fit that now behind the saw blade, make sure it's locked and the saw blade can't hit it, and then you can finish the cut. You may sometimes get a very slight step when you do a double cut. That's almost unavoidable, but a very light touch-up sanding, and it's a great way of splitting 4x2 down into 4x1s. In the normal rip position, that is where the locking keys go into holes labelled R, your ripping capacity is limited to 260 millimetres or 10 1/4 inches. Well, there's a way of ripping wider on the Triton itself, and that is very simply to unlock the table and turn it around through 180 degrees. Just turn it around this way, put it back on so that the saw blade now comes up through the edge slot, and the locking keys will go into holes labelled WR, WR standing for wide ripping, and you've gained that much rip capacity. Now, of course, you undo the safety guard, remove it from the slot, reposition it here, and lock it. Notice I've got my saw blade lowered because I'm about to rip a piece of particle board, and keep the blade as low as you can. Lock that in position. Now I must also reverse the fence because now I don't have any lead in, but I've got too much tail out. So simply unlock the fence, turn it around. The low side of the fence will now be facing the saw blade. Lock it in a slot, and suddenly you've got a ripping range from 185 millimetres to 455 millimetres, or all the way out to 18 inches. So now you can take your board, always have a straight edge against the fence. There we go, it's a nice straight edge. And notice my hand positions. I'll basically be concentrating again on the piece between the blade and the fence. Keep control of that piece, that's your main piece. If this offcut is wider than this narrow one that I'm going to be creating here, then you may need some outboard support with a trestle, a friend, or the Triton extension table coming up shortly. Just before showing you how to use the Triton extension table, a couple of quick pointers on fitting it. Firstly, loosen these wing nuts on the leg cross braces. Angle these hook over clamps to their maximum position, and make sure your leg saddles are parked at the top of each leg. Move the extension table in between the saddles, place the hook over clamps on top of the spools, step outside, and by lifting these legs it should all drop neatly into position. Fine. Now you can drop these leg saddles and lock them. and then tighten up this inside wing nut only. Then you can take the extension table. The word Triton should be on your left. Place it on the tapered pins. Make sure it's fully down, and then lock this outer wing nut. Then you can zero your top until it's exactly flush with the work centre table. Use a straight piece of wood to get them dead in line. Another couple of quick points about the extension table. Firstly, when it's clamped to the work centre, it's all still quite portable. Optional wheels are available, and you would fit the wheels for the extension table at the rear of the extension table and the wheels for the work centre at the front of the work centre. Now the reason for this is simple. It means that for going in straight lines, it tracks beautifully forwards or backwards, and to do a turn you simply take the weight off the work centre wheels by using the T-handles and turn. So the whole unit becomes completely manoeuvrable, very steerable. Of course, you never operate the machine on its wheels. You always retract the wheels and lower it down to its feet. And you can get adjustable feet for your work centre and your folding stand to level it up to another part of your workshop. Now I'm going to show you how you can single-handedly cross-rip an 8x4 sheet, one of the most difficult jobs you're ever likely to come across. And it is one of those sort of jobs where if you can get a friend to help you, it's a very good idea. But if you're working on your own, here's what you have to do. Firstly, the work centre and the extension table. The fence on the extension table is reversed so that you can get out to the full range of 1225 millimetres or 48 inches, and locked very securely in position, because with a large sheet like this, you can bump that fence and knock it out of alignment. So do that up nice and tight and double check your settings. Blade lowered, riving knife and guard in position, and the trestle that we mentioned earlier to support this very large offcut, which is going to otherwise overbalance you and hang off the edge of the table. Now I've prepared the sheet resting on two little pieces of packing down there so I can comfortably get my fingers underneath the sheet and lift it up and tilt it onto the Triton Workcentre table, very much like this. There we go. Now it's very important during this cut to keep that edge of the board, of the sheet, very hard up, constantly in contact with the fence. So keep your concentration on the fence and running that straight edge along it. Don't worry so much about the offcut, but check that your trestle is supporting it properly before, during and after the cut. Okay, almost ready to go. Now prepare yourself with a push stick. I'll use that to switch the power on. And just notice what I do at the end of the cut. I'll bump off the power with my knee and just wait until the blade stops spinning before withdrawing the pieces. Here we go. If for some reason you choose to build your own extension table, then here are a few vital points to consider. It must be very secure, it must be flat and level in relation to the work centre, and the two tables must be anchored together. There's no point in having a fence fixed to one table and the saw fixed on the other table. They could separate during a cut with very awful consequences. So make sure they're securely clamped together. The fence, which must be securely lockable at any position, and I mean securely because a large sheet will bump that fence, must be securely lockable, and you must be able to set that absolutely parallel, so recess some calibration scales into your extension tabletop if you're making one as a homemade one. In either case, you'll find it very useful to make up this small trestle. You can use it for supporting large sheets, for lead-in support and tail-out support in the table saw mode, and of course in the cross-cut mode you can use it for supporting long beams for cross-sawing, or staircase stringers for routing, or long wide pieces of shelving for cross-trenching. One of the problems you may come across in your woodworking is dealing with removing a small piece from a larger sheet. For example, you've got a sheet and it's 2 millimetres too wide. Don't set the fence in 2 millimetres from the blade, it's too close. Rather, pass the wood between the extension table fence and the saw blade and take your 2 millimetres off that way. What if the sheet happens to be slightly out of square? Well, there's another way of rectifying that too. You can do two things. You can tack or tape, using two-sided tape, double-sided tape, a straight batten to the sheet, exactly square to, say, this edge here, and then run the batten against the extension table fence. That has the effect of very slightly angling the board as you're running it through. The fence is still parallel, but the board is angled slightly because of that batten attached to it. There is another way, and that is to use a thumbtack, perhaps with a little bit of packing behind it to give you the required dimension. And you can stick this into your board there or there, and that will actually angle the board to the blade. You're not angling the fence, you're angling the board by putting a little bit of packing on there. If you're dealing with a fairly wide piece, you may have to put a long fence extension on forward or behind the fence so that you're in constant support and your board is basically resting on the thumbtack and packing and its own natural edge, and that angles the board very slightly, enabling you to square it up. What happens if you've got a larger sheet and you want to remove a small amount from one edge, but you don't have the Triton extension table? Well, here's how you can do it. What you do is you get a straight piece of wood and you rip it almost all the way through, about 2/3 of the distance, by the thickness of your saw blade, one blade width only. That way, by attaching this piece of wood to the fence, screwing it on, you can position the fence so that the saw blade is just lightly touching against the main piece of the wood, and the stepped out part will give you good tail out support together with your riving knife so that you're not tending to jam the wood on the back of the blade as you finish the cut. Here's how it's done, and try to note the hand positions. While I'm feeding into the blade, I'll be pushing mainly against the front fence. As I get past the blade, I'll transfer most of the pressure against the back fence, like this. You may have noticed a slight pause when I hit the step. Round that off very slightly because it can hang you up to prevent a smooth pass through. The limitation with this sort of fence is, of course, only one blade width at a time. You can't take off half a blade width or a quarter of a blade width. You can cope with that as well by making up a more sophisticated version of this. A straight piece of wood screwed to the aluminium fence, two identical sub-fences screwed onto the straight piece of wood. Now, not identical length, identical thickness, and position them so that the two pieces close at the front of the saw blade and just behind the rear of the riving knife. In order to pack out the rear sub-fence, make yourself up some shims out of sheet metal, out of plastic, wood even, or cardboard. You can drop those shims in there. You can make different thickness shims and then tighten up. Oops, there we go. Now, very importantly, use a straight edge to line up the packed out fence, the riving knife, and the saw blade, and get them all exactly in line. Then you can lock off the fence. And now, with each pass, you will remove an amount of material equal to the thickness of that shim packer you put in there. Let's say you're working with some solid material, and it's very badly weather-stained or out of square or painted in generally an unusable piece of wood. Okay, there's a very easy way of dressing a small amount off that and cleaning it up to quite a respectable piece of wood. Place it lightly against the saw blade, move the fence in and take a reading. That's reading about 72 millimetres. Remove the piece. Now, because this is so badly out of square, I'll take quite a hefty amount off. I'll move this in to about 70, and 70 at the front, always parallel. Now, by passing the wood between the blade and the fence, my tungsten carbide tipped blade should dress all of this rubbish off and should do it properly. Try to start off resting on a fairly flat face, or at least with a square edge against the fence. perhaps needless to say, every piece passed between the blade and the fence when the fence is set at 70 millimetres will be dressed to exactly 70 millimetres. But now that you've got one clean, straight, square face, that's square to that edge there, you can now rest the square face flat down on the Triton table, the original flat face against the fence, and then dress off this face. You may have to do this with 2 passes, end for ending, as you saw in the double ripping, but you should be able to get a reasonable result on some very twisted hardwood. If the material you're working with is bowed as well as twisted or out of square, then what you should do is attach a long, straight piece of wood to the fence and have the material concave side touching the fence first, and do a cut to just trim the convex side up, and then of course you can turn it over, put the freshly dressed convex side, which is now straight, against the fence and run it through normally. All the cuts you've seen so far in the table saw mode have involved cutting all the way through a workpiece. True, the blade has been lowered to just cut through, but we've cut through every time. If you lower the saw blade, a whole new range of cuts becomes possible. The most simplest of which is probably a grooving cut. Let's say you're making drawer sides and you want to get your plywood bottoms and let them into the drawer sides so they'll be strong. The grooving cut is the simplest. Now, you lower the saw blade, and we'll show you in a few moments how to get accurate saw blade height, but for this cut, I'll just approximately guess it at about 4 millimetres deep. And I'll lock the fence off and I'll pass the wood over the blade. Because we're not cutting all the way through, it's not possible to use the riving knife and the safety guard. So again, be doubly careful not to trail any fingers. You can keep your hands firmly on top of the work and hold it down, even if that means your hands passing over the line of the blade. The blade can't suddenly climb up and cut you, so you can keep your hands on top of the work like this. At least they'll be in view and you'll see what you're doing. A small hint: if you're doing 8 drawer sides and you need to make, say, a 6 millimetre wide groove in there because you've got 6 millimetre ply, that will involve, of course, 2 cuts. Now, instead of, for each piece, setting the fence, doing 1 cut, then resetting the fence closer in and doing a 2nd cut, do all 8 at the first fence setting, then move the fence in by 3 millimetres or the thickness of your saw cut, and then do all 8 at the 2nd fence setting. It'll save you a lot of time and effort. This is how it's done. And now the 2nd cut. Now it's a little bit tight, so just ease it in a fraction front and a fraction at the rear, and do a skimming cut. A lowered saw blade can also be used for decorative effect. You'll see later how you can use a router for this application, but if you don't have a router and you're building some drawer fronts and you want to dress them up a little bit, here's an interesting way of doing it. Have your drawer fronts good face down and lower the saw blade until the tips of the teeth are just visible above the table. You only need about 1 millimetre or so of blade protrusion. Set the fence in fairly close. I've chosen 10 millimetres for my first cut, and have a look at this. Now I'll set the blade out by another 7 millimetres, say. This choice is up to you, but have a look at the result. By just making those grooves, those parallel grooves, you put a nice interesting detail on the front of your drawers, and of course you can get some red paint or black paint, marker pen even, and fill in the particle board beneath the veneered surface and make it a real feature of the drawer front. The edge rebate or edge dado is an extremely useful joint to use, especially if you're working with veneered particle board and you want to disguise that crumbly edge without having to glue veneer strips or beading strips on it. What you'll be doing is setting the board down into the framing timber. And it's quite easy. You actually use the board itself as your ruler. Lay it on the table, up against the saw blade, and lower the saw blade until the uppermost tooth is just fractionally above the surface of the board. Just a fraction above. That's a bit too high. There we are. And just feel that tooth. Now, move the fence in. Just temporarily lock it off at about 14 millimeters. And now sit the board against the fence, and it should be flush with the left-hand side of the blade, the outside of the blade. No, we have to come in a fraction. Perfect. The board is now up against the fence. The board is now flush with the left-hand side of the blade. Now I can do my first cut. I'll explain in a moment why, but the first cut of a rebate should always be done with the wood resting on its narrowest face. The first cut on the narrowest face, in other words, up tall. What I'll do now is, having done that first cut like so, turn the wood around and over, and I'm about to run it through like this again. What's going to happen though? That small off-cut in there, when I finish the cut, will be trapped between the blade and the fence. I'll actually do this without taking any precautions, and probably you'll see that the off-cut will go shooting out here. The only precaution I'll take is I won't stand directly in line with the blade. I'll stand to one side. But then, having done that, I'll show you two alternative methods for solving that problem too. That off-cut did not come out at a great rate of knots, but you can see what I'm trying to show you. It can sometimes come out extremely fast. Let me first show you the cut. There's the rebate. Looks fine. Made for this particle board. It's an absolutely beautiful fit. Perfectly flush, edge disguised, and you've got a beautifully strong step on which to rest your particle board. Now, how do you cope with that problem of an off-cut which goes flying? Let me repeat the first cut again, off this face. You'll notice that I switched off the power just as I saw the saw blade appearing, and then you can just finish off as the blade's coasting to a halt. Incidentally, if you get a small ridge here, a small section uncut or poorly cut because the saw blade was slowing down, well then feel free to run it through again with the blade at full speed, because now there's no solid off-cut to worry about. You can just go through and do a clean-up cut. There's another good way of coping with the flying off-cut problem, and that is to do your first cut as before with the wood standing up tall, first cut in the narrowest edge. You'll see why in a few minutes. And then for the second cut, back the fence off, place the workpiece in position. You may have to adjust your saw blade so that the highest tooth is just opposite the top of your groove, like that. Set that in position. And then you can set your fence in close, set it into the wider dimension, like so. set up for your cut, and now you can make the second cut with the wood lying down flat, and the off cut will fall harmlessly aside. Mind you, you should only do it this way if the wood you're working with has parallel sides. Otherwise, it will show up, any slight taper in the workpiece will show up in the rebate. Just to recap on a couple of points with this rebate. Firstly, I mentioned earlier that you have your saw blade set a fraction higher than the piece you're rebating in. The reason for that is you want a small amount of this framing material left standing proud so you can finish sand that down without rubbing a big hole in the paper-thin veneer. That's one little tip. Another one, of course, is don't be tied slavishly to this example of an 18mm by 18mm rebate. That was made because this piece of particle board is 18mm, and I might want to fit it in this way, or I might want to fit it in this way for a door front, for example. But you can vary those rebates any way you wish. You can make them wider, deeper, stepped if you wish. For example, you could make this rebate 6mm deeper that way and put a piece of 1/2-inch particle board in position, and then glue or grout some tiles so you can make a nice flush countertop or the top of a bench top or a coffee table. Tongue and grooving, an immensely satisfying joint if you do it properly, and of course extremely strong, because as the different pieces of material, which in the case of this chopping board here, they're all tongue and grooved lengthways, and the end caps are tongue and grooved on as well, as those pieces shrink and warp and twist and cup at a different rate, they can't really move in relation to each other because they're tongued all the way along. There's a lot of gluing surface there, plus the interface of the piece of wood sitting in the groove. So let me show you how it's done, and I'll explain a few important principles as we go. Firstly, for tongue and grooving, you'll probably have to set your saw blade height very precisely. We certainly don't recommend that you try to hold a ruler on the table and set the blade height, the blade teeth to a ruler, because that only leaves you one hand to adjust your power saw, and most power saws need two hands. Couple of very simple ways. Let's say you want to cut 14mm into a piece of wood. Simple. Take an offcut, any offcut will do. Make a mark 14mm from the bottom. Sit the piece of wood on the Triton table, and then you've got two hands to raise and lower the saw and get it absolutely right on the line, the uppermost tooth, and at the point of its arc, the maximum point of its arc, should be touching the line, and there's 14mm. A couple of other ways. Use the setting block described earlier in this video with the rulers glued onto it, like so, and again set your uppermost tooth against the digit you want. Another method was suggested to us by Mr Ross Runting, one of our Australian customers. He has limited eyesight, so what he's done is quite ingenious: a block of wood with a central section which can move up and down. Now attached to that central section is a piece of aluminium angle, and rebated beside it are two rulers, one imperial, one metric. Now what he does is, under good lighting conditions, he can set this exactly to the depth he wants, and then screw this gauge to the rip fence with a wing nut using a hole provided, and then raise or lower his saw blade until the uppermost tooth is just touching the underside of the aluminium, and he's set his saw height. When tongue and grooving, it's vital that you test your blade height settings and your fence settings on some pieces of scrap. Now preferably use some offcuts of the material you'll actually be using for the job, or some scrap exactly the same thickness. Another point too, you'll probably be tongue and grooving some fairly wide boards together. So give yourself some backup support. Again, a high fence, dead square to the table. That'll give you plenty of support as you're going through. How do you calculate your settings? Well, I'll try and explain it simply. Here I've got a piece of 35mm wide material. I want to end up with a tongue that's, say, 7mm wide. 35 minus 7 is 28. Half of 28, because you're doing two identical rebates, half of 28 is 14. Now don't set your fence at 14. You must allow for your blade thickness. So in this case it'll be 11, except I've got this fence packer on, so ignore my fence settings. But I've basically got a distance of 11mm from the edge of the fence to the inside edge of the blade. Then if I do one cut from this face, turn the work around and do another cut from this face, the tongue that I have left will be exactly central, as you'll see.
bit fast that time, didn't it? Again, never stand directly in line with the saw blade. You could collect that small offcut. But as you can see there, the tongue is dead central and it looks about 7 millimeters wide to me. I've mentioned a couple of times how important it is to make the first cuts with the wood standing up tall. Let's say I'd ignored instructions and done my first cut like that, lying down flat. My second cut like so, again lying down flat. I'd probably get away with it for the third cut. I could make that cut and I'd still be standing on a secure base here. But the fourth cut, look out. Okay. Now what would happen in the fourth cut is the minute I cut through that piece and created that off cut, I'd be standing teetering on my narrow tongue. Now that tongue is probably narrow enough to fall down, nosedive down the slot in the table. If it does that, the wood will drop down onto the saw blade. The saw blade won't cut, it'll rip the piece of wood out of your hand and fling it towards you at up to 100 miles an hour. So that's why you should always do the first cut standing up tall and the second cuts lying down on your flat, secure faces. Now for the groove. What you do is you take your test piece, which has got a tongue on it, put it in there against the saw blade, and then readjust the fence so that now the saw blade teeth are occupying the area formerly occupied by the tongue. Actually, you'll be moving the fence out by 1 blade width exactly, but it's always good to double check this way. And it's generally a good, safe idea to make your groove slightly narrower first. You can always widen it out later. Okay, that's set. You can raise the saw blade a fraction if you wish, just to give yourself a bit of room for the tongue to occupy. But basically, put the wood in, and again, 2 cuts to ensure that everything's central. Make sure your fence is parallel and locked off. When you're tongue and grooving, you're probably going to be doing some very long pieces for a bench top or a tabletop, for example. And long pieces are very rarely dead straight. So don't make your test pieces too tight a fit, or you'll never be able to clamp the long pieces together when you've tongue and grooved them. There's an alternative to tongue and grooving, especially useful if you're dealing with thin boards, and you'll see that later. But it's to make a spline groove. Take a piece of plywood, say 6 millimeter plywood, and make a series of grooves only in all of your boards that you want to join together, and glue that plywood tongue in, and it's simpler than tongue and grooving and pretty well just as strong. For working on the edge of very thin materials such as this, doing spline grooves or indeed tongue and grooving, you've got the problem, of course, of the material being able to fit down the blade slot. Very dangerous. So here's a few precautions you can take. Firstly, high fence extension, because you'll be working with a tall, thin board and you want that nice and square at the tabletop. So extend your fence, make sure that's nice and square. Now you'll be making up a mask so that you can actually reduce the slot to just a slit big enough for the saw blade to pass. You can use your jigsaw to do this. There's a simpler way if you're careful. Get yourself a piece of hardboard or plywood. Decide how much blade protrusion you want above the plywood, so allow for that in setting your blade height. Let's say we want to go up a maximum of, say, what's that, 15 to 20 mil, including the hardboard. Okay, set the fence in position at the position you will want to do your tongue and grooving, or your spline grooving. Set that up like so it's in the right spot, and locked securely. Now you'll be doing a plunge cut, so prepare yourself for this. Hold the wood square to the Triton table, and flush up against the board, practice it a few times, then you can switch on the power and plunge down, like this. Now preferably use some heavy-duty tape, like some duct tape, as mentioned earlier, and tape that down to your table securely. So it can't move. It's hard up against the fence, of course, and you might even want to put another piece for security along the back. And now your slot in the table is filled in, and you can effortlessly and safely pass your work over the top. While this method of masking the slot is very effective, it doesn't give you very much fence adjustment. There is a more sophisticated version, and that is to make the same sort of hardboard mask, but cut some slots in it for the rip fence clamps and for the calibration scales. That way you can put this underneath your rip fence with your saw blade through this narrow slit, and you can still move your fence out and in and adjust it for the cut you want. Beware of parallax error in reading your scales, because now you've got the thickness of the hardboard to contend with, so look from directly above in setting the fence. Apart from edge jointing thin materials, there's another very useful application of this type of cut, and that is in making shiplap siding. What you do basically is you make two grooves, a deeper groove from one edge and a shallower groove from the other, and then lie the work down flat and rip half the groove off from this side and half the groove off from that side down the bottom. Provided you spend a little bit of time setting it up properly, you can work very effectively on end grain to do a butt join like this, where two pieces are butted together, and very strongly so. Or you can join at right angles if you wish. You'll need longer tongues, of course, but you can join at right angles like that with spline grooves and keys. How do you do it? Very simply. You have a high fence extender again, because you'll be working with the piece on edge, on end like that. And here's a very useful jig, a little rider which sits on top of that high fence extender, is captivated so it can't fall off. You can push it safely back here, and this block screwed on squarely is your running guide for holding the piece of wood against the fence and pushing it through. Now you will be cutting into that block. You can see the test cut I've just made there, so don't glue that on. Screw it on so you can replace it as necessary. Hold the work firmly against the fence and do your cuts. I'll do two cuts, one from this face, turn the wood around, one from this face, so that everything will be dead central, perfectly symmetrical. Now, if I wanted to make a wider groove for a wider key, then very simply make the first two cuts, move the fence out or in if you wish, and do another two cuts. Remember, whatever you do to this side, you must do to that side, and the two grooves will be perfectly symmetrical, everything central. You'll probably remember from the cross-cut mode this joint, the spline bevel joint. Well, you can also make a splined mitre, and now's the time to show you how to do it. This is a splined mitre. As you can see, it's a mitre from the front face, but keyed from the back. It's very strong. You'll need to make a sort of arrow-shaped key to go in there. Here's how you do it. Again, you use a rider block, but this time the pushing piece is angled at the angle that you want, that you've cut the mitres, and place that on your extended fence, place your material in position, make the cut and keep pushing all the way through. And there you have the groove. Now, a small point, but a fairly important point. You'll notice when I made that cut, I pushed the workpiece and the block all the way over, then lifted it off and pulled it back. And that's just because you should never really pull anything backwards onto a spinning saw blade. You'll recut it, the saw blade could grab the piece and tear it out of your hands. So when you're moving backwards over the blade, lift up and come back this way. Because of the excellent cross-cutting facilities of the Triton Workcentre in the cross-cut mode, most of your cross-cutting should be done in that mode. However, there'll be instances where you want to do some cross-cutting and you're set up in the table saw mode, so you can do it on the Triton. What you do is you slide the miter gauge, the protractor, in this slot here. Always give it a bit of spray lubricant before starting work. Make sure it's nice and free to slide, like so. And in the first instance, we'll set the gauge at 0, lock off both knobs, and then position the workpiece. Holding the workpiece against the sandpaper face, which prevents slippage, preferably wrap your fingers around the front of the workpiece and tuck your thumb behind the upstand of the protractor. Now, in positioning this for the cut, be very careful to avoid having a small offcut which might fall down the slot beside the blade. Now, the range of offcut sizes that you're worried about are anything between about 1 millimetre and up to about 5 millimetres in width. Less than 1 millimetre, it'll be a paper-thin shaving and it'll fall harmlessly down between the blade and the slot. More than 5 millimetres and it'll sit comfortably on this side of the table. So avoid having an offcut which is going to be in that dangerous range between 1 and 5. In this instance, I'll create quite a generous offcut to do the cut. If you want to cut a smallish number of pieces the same length and you're in the table saw mode, you can do it in much the same way as you do it in the cross-cut mode. Rough cut them to length first, then line up the dressed ends, the outside ends away from the blade, get them dead in line, then hold them firmly together or tape them again if you wish, and then slide them through and make a smooth cut. Something I forgot to mention earlier, the use of a stick to flick your scraps away. It is much safer than reaching in and trying to pick them up with your fingers. Use a stick, much safer. What about cutting a wide piece? A piece which is normally too wide to fit between the miter gauge and the saw blade. For example, a piece like this. Now, by rights, this should be cut in the cross-cut mode, but if you've only got one piece to cut and you're set up in the table saw mode and you couldn't be bothered changing to the cross-cut mode, you can do it. I'll raise the safety guard a little bit to give me access. Now, I'm going to do a plunge cut, much the same way as I did a plunge cut in the cross-cut mode. Park the miter gauge as far back as it will go. Position your wood in there. Make sure it's clear of the blade before switching on. Sight up to a pencil line, which you've got there, for example, and then clear of the blade, switch on. Once you've had a bit of practice, well, perhaps more than a bit of practice with your Workcentre, you'll be able to do things like making parquetry and inlay work. For example, this table here. You'll have to cut a number of pieces, shortish pieces, to exactly the same length. And it's crucial that they be exactly the same length. Here's how it's done. Before showing you how it's done, perhaps I should show you how it's not done. There's a natural inclination among inexperienced Triton owners to run the wood against the miter gauge, the protractor. That's fine, but a lot of people think you set the fence as a stop. Now, that's extremely dangerous for this following reason. You've got your wood in there, you make the cut. Once you've made the cut, what happens? You've got an offcut trapped between the spinning blade and the fence, and it's not being controlled. If that offcut twists even slightly, it'll be flung out by the blade towards you and can cause a serious injury. So, what do? If you want to use a fence as a stop, then prepare a piece of packing material, reasonable thickness, say 19 millimetre, 3/4 inch. Move the fence out by that same amount. Let's say you wanted 120 mil pieces. Well, move it to 139 mil, allowing for the 19 mil of your packing piece. Excuse me. 139, 139, and clamp that little packing piece to the fence like so. You can butt the work up against the stop block, make the cut, and suddenly you've got this escape area here where the piece is not going to be trapped between the blade and the fence, and you can handle it properly. It won't get flung out towards you. While this method of repetition cutting is quite effective, it's not the best way. The problem with it is that although you're no longer trapping the offcut between the spinning blade and the fence, you've got some escape there, you're also not controlling it. Nothing's holding it in position. And you may find that some of the pieces will vibrate crookedly and may dance against the side of the saw blade and get slightly recut, which will show up in a parquetry or inlaid tabletop. So the best way is not to use the fence at all. Just remove the fence, but attach to your mitre gauge one of these jigs. Now let me just show it to you. It has a vertical upstand so you can put your screws in, and a fairly wide, thin leading face so that you can cut into it with your saw blade without weakening this face too badly. And then you have a little stop block which you can nail on at any position, and that will determine how long the pieces are that you'll be cutting. Very simply, put it in the slot, take your work, butt it against the stop. You can still use a safety guard, of course. You can now use your right hand on this side to hold it firmly against the block, and this is the action. If you're afraid of cutting too far into this board, what you can very simply do is decide the maximum travel that you want to achieve and then clamp with a G-clamp another block of wood to the table there to limit your travel. You can't go too far that way. As you'll recall from the cross-cut section, mitre cutting is very easy on a Triton. You can, of course, do it in the table saw mode, and when making picture frames or cutting small pieces, it's probably better in the table saw mode. I've already explained how the mitre gauge works. The protractor, it has two faces, exactly 90 degrees to each other, so that any error in setting, if you're on 44 3/4 degrees on this face, then this face will be 45 1/4 degree, and will always add up to 90. So use the two faces to get perfect mitres. Having said that, do try to get exactly on 45 degrees, or as close as you can, because the mitres won't match perfectly in the corner unless you are set that way. The holding position is basically the same as for cross-cutting. You hold the wood firmly and tuck your thumb behind. Now, when mitre cutting in the table saw mode, you always have the good face upwards, and that's for two reasons. Firstly, the uppermost face in the table saw mode is the face which gets the least splintering, so you want your good face up. And perhaps more importantly, resting moulding on its contoured, curved face doesn't give you a very good support base to rest on. So always cut it this way, and you'll see that by using face B, you can get your reverse angle mitre with no problems. Make your first cut on face A and your second cut on face B, like this. There, as you can see, the upper face is clean, and any splintering and tearing is on the back face, and it was cut very safely, resting on its flat bottom with its highest side against the face of the mitre gauge at all times. Now, when you're cutting a picture frame, you'll need to cut several pieces to exactly the same length. Having cut one piece to length, this end against face A and this end against face B, I can now use this as a master to set a stop for cutting the opposite piece of the frame. Very simply, it's done by attaching a wooden sub-fence to your mitre gauge, to face B of your mitre gauge, and preparing an angled stop block and a G-clamp. Then you place this piece against the sub-fence, push it in, touch the mitered face against the saw blade, don't deflect the blade, and then you can just move the stop block into position, and that'll give you your exact length. Just touch it lightly against the piece. Make sure you're not jamming in there. Now you can take that away and take another piece which I've pre-prepared. I've already cut it on face A. Now I have to do face B. So I butt the face A piece in. And these two pieces are, of course, exactly the same length. Similarly, take one of your shorter pieces, cut one end on face A, the other end on face B. Again, park your protractor in position, touch the wood against the side of the blade lightly, move the stop block in, again lightly, clamp it in position, and then you can very easily cut your second piece, and that will also be the same length. If you use this method to cut all of your miters for picture framing, one end on face A, one end on face B, and if you use a stop block, you won't have to measure and mark, and you won't have to worry about gaping miters. It'll always match perfectly, and your frames will be perfectly square with perfect corners. All of the miters you've seen so far have involved 45-degree angles, but you can have any angle that you like as long as the two angles add up to 90 degrees to give you a right angle. For example, I've set the protractor here at 30 degrees, so the piece cut on face A will be at 30 degrees, and the piece cut on face B will be at 60 degrees. Well, 30 plus 60 equals 90. You've still got the problem there, of course, that this piece is wider than that on the angle. So you can either start off with narrower material or rip that down to size. The mortise and tenon joint. Arguably one of the most difficult and time-consuming joints to make in woodworking by hand, but as you'll see in a moment, the tenon is very simple to make on the Triton with your saw, and the mortise is very easy if you have a router. A word of advice when planning this joint, always make your mortises first. The reason being that ideally a mortise should be made with one pass of the router rather than one pass and then another smaller pass, because that way you'll have problems keeping everything central. Make your mortises, say 13 millimeters wide, as in this case here, and then when it comes to making your tenons, what you have to do is be left with 13 millimeters of tenon standing from the end of your wood. So set the saw blade so that in two cuts you'll have 13 millimeters left from the material you started off with. You'll be doing one cut from this face and one cut from this face. Now you can again set the fence as a stop because there's no solid offcut being created, just some sawdust, and set the fence as a stop, allowing for your saw blade thickness so that the tenon that you get ends up being slightly less than the depth of your mortise. Sandpaper override on the front of the miter gauge so I can do the clean-up by sliding the wood sideways, and tenoning is as easy as this. Hold the wood against the gauge, check that it's nice and square to the fence. Fence is locked, blade is set to the right height, away we go. As you can see, that tenon must be perfectly central on the end of the wood and perfectly square, and then just round off the corners and fit it into your mortise. Hopefully this is a good fit. There we go. As you've seen, face B of the mitre gauge is an extremely useful adjunct to your work centre. It can be used for cutting sharper angles than 45 degrees and also can be used for ripping short tapers. Let me show you. In this instance, I've got an extension fence mounted to face B. I've got a stop block set up there. And I'm going to cut a picket for a picket fence, for example. If you're working with very long pieces, of course, you can do all of this in the cross-cut mode where you don't move the wood, but this is a short piece, so I'll do it in the table saw mode. I've lined up my saw blade with the centre line of this piece of wood and use this as my standard, and then 2 cuts. And there's a 60-degree angle formed at the top of my picket. There are a couple of excellent ways of ripping tapers on a Triton, both long tapers and short tapers, and I stress again, you do not do it by angling the fence to the blade. What you do is you use face B of the mitre gauge again with an extender and a stop block. Now, I've got this set of 15 degrees, and I will find if I try to do this cut that I won't be able to move the mitre gauge far enough to complete the cut. Well, for these sort of cuts, you may move the saw forward to the forward lock position. Unlock the table, slide the chassis forward, lock it back in, double check that it's locked, and you can reposition the guard forward or completely relocate it forward, but I've got enough protection there. Lower the safety guard, like so. Okay, now I've got my piece firmly against the stop block, and I can keep my fingers clear, well out of the line of the path of the blade. As you can see, I just ran out of travel, but there's my short taper. I have to clean that piece off. And of course, it's an excellent way of making your own wedges as well. Let's say you're working with long work pieces, too long to comfortably use an extension fence and a stop block in the table saw mode. Well, you can do this in a cross-cut mode, where you don't move the wood, you move the saw. But if they're manageable pieces, no more than, say, 1.8 metres or 6 foot long, you can do them in the table saw mode this way. Take all of your work pieces and mark a reference line, a known distance back from that edge, say 100 millimetres, and do the same on the other face of the material. Then take one of your pieces only and make a pencil line showing the halfway point of that piece, assuming, of course, that you want a symmetrical picket. Okay, now put this into against your mitre gauge. Set the mitre gauge in position until the saw blade is directly opposite that pencil line, and then translate your reference line up the face of the mitre gauge, like so. Translate that up. You can then make your first cut, then turn the wood over, compare the reference line to the pencil line, and make your second cut, and all of your pickets will be symmetrical. Another safety issue. In this cut, you don't have the sandpaper to stop the wood from slipping, nor do you have a stop block. So you'll have to hold the work very firmly against the mitre gauge extension fence, or put some sandpaper on it if you wish, or you could even consider clamping them together. And preferably, work from around this side, keep your hands clearly in view, rehearse the cut if necessary, and make sure your fingers don't come anywhere near the line of the saw blade. The secret of taper ripping is that while you move the workpiece parallel to the saw blade, there's nothing to say that you can't angle the workpiece itself. You may recall that thumbtack example given when squaring up a large sheet earlier in this video. How do you angle the workpiece? Well, very simply, if you've built this repetition ripping jig, which we showed you earlier, then you can modify that, make it a 2-part jig, where you recess a hinge in there and put another straight piece on to the main body of the repetition ripping jig. Here, a slotted adjustment arm, so you can change the angle to whatever you want. I'll set that on my predetermined angle. And here we have a stop block, again, angled face to hold the wood down, and that actually pushes the workpiece through past the blade. Now, it can get a little bit confusing if you've never done any taper ripping to know exactly the line of the saw blade. So what I recommend is that you get your piece of wood, put it in position, take a straight edge, and extend the line of the saw blade and the riving knife and just make a pencil mark on your wood, right there. Then you can rehearse this cut. You can rehearse your finger position. I'll be holding it right here and right there, pushing it against the block, and then sliding it through, like this. And there's my taper. Bevel ripping is one of those cuts which officially you can't do on the Triton Workcentre because you can't angle the saw blade significantly in the table saw mode. There are a number of ways around it, and I'll show you them in a moment, but before doing so you should always consider when contemplating a bevel cut, can it be done in the cross-cut mode? As you know, as you saw earlier, you can get between 450 mil to 600 mil of capacity, 18 inches to 24 inches wide, and most bevel cuts indeed are on a board of that width. If you have to do a longer piece, then here are some of the methods you can consider. Firstly, if you're doing a shallow angle, for example for the top of a skirting board or for a windowsill for a rain drip-off groove, then what you can do with a shallow angle is attach a batten to the board you want to cut. Now this batten has got to be flush all the way along. In this case I've nailed it on, but if you're worried about the nails marking the main piece of wood, you can use two-sided tape, double-sided carpet tape, and that'll stick the batten on quite firmly. And then, very simply, all you're doing, you're still running it through parallel, but you're angling the wood to the blade. And just hold it firmly against the fence like this, and do the cut. One of the more common angles you may need to bevel rip is 45 degrees. Firstly, this one, you'll have to obtain a length of right-angled aluminium, say 40 by 40 by 3, generally fairly commonly available. Rebate that into a board, have that board angled to another board and use hinges so you can get different settings that you need, like 30 degrees, 22.5 degrees, 45 degrees. And then clamp or bolt this main carrier board to the Triton table. So at the edge of your saw blade, this edge is exactly in line with the V of the groove. Then you can fit the riving knife in the safety guard, take your piece of wood, put it in the V like so, prepare a push stick for finishing off, and do the cut. It's also a very good means of making your own quad if you need to. The load on the saw is very high with this sort of cut, so adjust your feed rate accordingly, don't overload your saw, and make sure you've got a sharp blade. Let's say you want to panel a door and you need to make a number of pieces like this. Well, okay, you could do the long faces in a bevel ripping jig like this one, but when you come to the short ends, how do you do that? Two ways. You can do it in the cross-cut mode, of course, holding the wood down flat and angling the saw blade and running the saw blade through. Or you can still do it in this mode, but if you were to do it like this, you'd start off okay, resting in the bottom of your V, but then when you got alongside the blade doing the cutting, you'd be jamming against the side of the blade, and that will ruin your cut and could cause an accident. So don't do that. If this is a jig you're building, make sure that this edge here is exactly parallel to the V groove in the aluminium channel, and then you can clamp a straight piece of scrap onto the piece of work you'll be using, the piece of wood you'll be using, and rest the scrap on this top edge. Then you're not relying on the V for support, and you can make the cut very simply. You'll see in the router section how you can use a 45-degree router cutter to achieve the same result. You can use your Workcentre for faceplate sanding if you replace your saw blade with a sanding disc. Now you can make your own sanding disc with some limitations. You can obtain at most hardware stores a stone or metal cutting disc and glue sandpaper to both sides, coarse on one side, fine on the other. A word of warning, don't use contact adhesive because you will have to peel that sandpaper off when it becomes clogged or torn, and if you've glued it down hard you won't get it off easily. So use some disc cement, but the limitation with making your own homemade disc is that they tend to flex a little bit and you can get off square if you push the wood a little hard. You can obtain through us or through your Triton stockist a properly fabricated aluminium disc that is available in range of sizes from 7-inch to 9-inch and has excellent peel and stick sandpaper pads which can be peeled off when they become worn and fresh ones put on, and they stick beautifully, and they're available in coarse and fine grades as well. Here's how it works, but small word of caution, the dust created in sanding is very fine dust, so you should really protect yourself, protect your breathing by having a simple dust mask. If you haven't got a dust mask, you can just tie a handkerchief around your face. If you've got a lot of repetition sanding to do, this is the only way to do it. Incidentally, you can use some mitre gauge of the Workcentre to clean up end grain, like this. Just park the mitre gauge in the right spot and move the wood in gently. You can cut tiles very accurately and easily on your Triton Workcentre. You can do it in the table saw mode or the cross-cut mode. In the table saw mode, protect your tabletop from being scratched by having a mask of hardboard or plywood with the tip of the masonry disc just showing above the mask. Then you can set your fence in position and run your tile through on its face. In this instance, when cutting tiles, you've got tiny little chips of ceramic material. Wear proper eye protection, wraparound safety glasses, and also a dust mask because the dust could be a problem. So get a proper dust mask. Now you're ready to go. You may have to experiment a little and break a few tiles before you get the appropriate blade setting and the feed rate for the particular tiles you're cutting. But play around with it. You might want to do 2 passes or do 1 pass with the tile face down, then turn it end for end and do another pass with the tile face up. And that way your 2 grooves will be directly opposite each other and the tile will break more easily. When you're dealing with quarry tiles or floor tiles generally, or with slate tiles, then you'll probably find that it's better to cut them in the cross-cut mode. When cutting tiles in the cross-cut mode, you don't try to cut through the tile in 1 pass. You do it in a number of passes, lowering the disc on from above. Now for this you'll need a saw that's got a fairly secure rise and fall mechanism. The vertical lift saws discussed in the plunge cutting section may not be suitable for this operation. Make sure you've got a smooth slide because you will be sliding your saw backwards and forwards, and there is a lot of dust created and it's quite abrasive. So lubricate your channels before doing the cut and clean them out after you've finished tile cutting for the day. Put some packing on your work table so that you don't scratch the paintwork, and of course dust mask and safety glasses are necessary. This cut will create a lot of dust. You may not be able to see what I'm doing, but you'll see the concept at least. loosen the blade angle adjuster, do a dummy run, make sure everything's okay, switch on the power, and then gently lower the disc onto the tile and let the weight of the saw do the cutting basically while you move it backwards and forwards. Don't press down hard. And that's cut through right quite cleanly. If you take a bit of care and are reasonably patient, you can even cut bricks on your Triton using the method I've just shown in the cross-cut mode. A couple of precautions: protect your tabletop from scratching and make sure the bearing channels are as clean as possible before and during the cutting. Try to keep the brick dust out of the channels as much as you can. Cutting thin gauge metal is also very simple on the Triton by fitting a metal disc to your saw instead of your saw blade. And incidentally, if you want to cut aluminium, then use a tungsten carbide tipped blade. But for steel, use a friction disc, protect your tabletop again, and preferably G-clamp the material in position to the tabletop. Now you can either drop the saw onto the work like this, or if your saw doesn't have a very secure rise and fall mechanism, then you can have the saw disc at full depth and just cut through as if you're cutting through a piece of wood, but take it very slowly. And if you're doing it in the latter method, you must clamp the work down to the table. It's as simple as this. That's given a nice square cut, slight burr which can be filed off but very fast. When using the jigsaw in conjunction with your Triton Workcentre, you use it upside down with the router and jigsaw tabletop. Under certain circumstances, when you're doing straight line work, you can use a fence and you can even use a safety guard for certain cuts to give you some measure of protection. But seeing as the jigsaw is mostly used for cutting intricate curves and shapes, you basically have to follow a line and not use a fence or guard. So that means you have to be super careful about where you put your hands. Don't be blasé about a jigsaw. They can hurt just as easily as a circular saw. Keep your hands well clear of the blade. Try to support both sides of the workpiece and try to feed your work smoothly. Now, it's not often possible to follow a pencil line exactly. You may have to decide to call one side your waste piece and concentrate on keeping the other side intact, which might mean taking some cuts from some wider cuts and then cleaning it off as you go around. Basically, the action is like this. And that's given me a perfect piece that I can just clean up there a little bit and there a little, and it'll be fine. Now, when jigsawing, especially in thick materials, it's very easy to flex the blade sideways. It doesn't take much twist on the workpiece to bend the blade over, and of course that will lose your nice square edge. So take it very easy on sharp curves, and if necessary, as I said, cut into the other piece and make several approaches to a curve so that you can get it just right. Now, a quick look at some of the fitting difficulties you may come across in fitting your router. Be guided by the instruction sheet that came with the router and jigsaw table, but here are a few of them. Firstly, if your router has a very shallow base and it prevents the top clamp from doing its job properly, very simply cut yourself some pieces out of hardboard or plywood, and glue them onto the router base beneath the top clamps, so it gives you a bit of extra height for the top clamp to bear down against, like so. This particular router has an inclined base, and that's quite common these days. So what you have to do there is remove the top clamps, put them in your vise, and bend that leg forward, angling it so it bears down squarely on the inclined face, like so. Now this router has another problem too. The locking mechanism for the height adjustment would foul a normal clamp if the normal clamp was in there. So what we've done is dispensed with the top clamp altogether and bent over the bottom clamp, so it's acting as a hook down clamp, and that gives you clearance for your locking cam. This particular router here has a large D handle, and it will fit on the plate, but only if you angle it diagonally across the plate with a power cord coming out over this corner. Another interesting point about this router is that it comes with 4 holes in the router base. So I'm not using the router clamps at all that are provided with the table. I've bolted it directly to the plate using the holes in the router base, and I've used flat washers and spring washers and hex nuts rather than wing nuts. It's very important to keep your router cutters in good shape. Keep them clean, keep all the resin off, and don't let them just rattle around in the bottom of a drawer, because they will clash against each other and you will lose your nice sharp edge. Preferably make up a little stand like this with a few holes in it that you can plug your router bits in and leave them where they won't be touching each other. Keep them clean. If you see this cutter, it's completely gummed up, it's full of resin and burnt pieces of wood. Keep them clean, and also you can wash the faces of the cutting flutes with mineral turpentine and with steel wool perhaps on the end of a pointer to clean them up. But a gummed up cutter like that won't cut properly. When fitting and removing your router bits, firstly, always switch off the power. Secondly, make sure that the router shank is quite clean, and don't handle a shank with your fingers because they will rust from the sweat on your fingers. Push it all the way into the router chuck and firmly tighten. It is not a good idea at all to partially withdraw a router bit from the router chuck. You'll damage both the bit and the chuck and could have a router bit flying around the workshop if you partially withdraw it. Lock it off firmly and try to make sure your spanners don't skid and fall off the nuts as you're tightening them, because you can actually break a router cutter fairly easily if the spanner slips. A final point, if using a shank reducing collet, line up the split in the collet with the split in the router chuck, and that way it'll tighten securely. As you no doubt know, you can use your router right way up or upside down in the Triton in much the same way as you use your power saw. When do you use each of the 2 modes? Well, basically, you use the overhead router mode when you're building shelving, cupboards, built-in wall units, where you might be cross-trenching long, wide and heavy pieces of material, which it's obviously inconvenient to move over a stationary router. It's better to lay the wood down flat and move the router over the top. When using the router in this mode, you'll almost certainly find that the table is too low for the router cutter to reach. Don't raise the table, rather put some packing under the piece that you're going to be routing. The packing does 2 things. Firstly, it offers the workpiece up to the router cutter, and secondly, it'll prevent you from cutting through the notched workstop. This cutout in the workstop is to allow the router cutter to pass through, and so you need packing which at least gets you to this point on the workstop. Then you can put your board in position, and you'll have to hold it very firmly or preferably clamp it. So let's just put a clamp on now. The need for the clamp will be obvious the first time you use the router, because you'll find there's a tremendous tendency for the wood to move sideways. The router cutter will want to move the wood. So clamp it down or have sandpaper lined fences. More on that in a few moments. Because you're not cutting all the way through the workpiece, but just doing a trench, then you want that trench to be the same depth all the way along. Before doing a cut, double check that your Triton table is set accurately and in the same plane as the traverse of the router. How do you do that? Very simply, lower the router cutter onto the board till it's touching, and then push it across the board with the power switched off, and it should scrape evenly all the way along. If it doesn't, you might have to raise or lower your Triton table at one end very slightly. Once you've got your true setting position, you can then perhaps use the depth stop on your router, or just eyeball it and go down the amount you want to trench. Lock it off firmly, and then you're ready to cut. Safety glasses again, and try to help your G-clamp by holding the wood fairly firmly and do the cut. On this first one I'll go all the way through, then I'll show you some stop trenches. If you're doing a deep trench, don't try to do it too ambitiously. Don't try to do it in one pass. Do it in 2 or 3. Go down a little bit more, don't move the wood, and do another cut. If you're working with real wood rather than particle board, you may find that you get some substantial breakout where the router cutter leaves the workpiece. There's a way of rectifying that, and that is to insert, backing up the workpiece, a straight piece of wood which you can screw to your work stops. You must screw this on, but then that'll give you good backup support at the point where the router cutter breaks out, and you'll minimize the splintering. If you're working with particle board that has a hardwood strip on the edge of it, or if for some other reason you don't want your trench to go all the way through, then very simply all you do is fit a stop block, clamp a stop block onto your aluminium bearing channels to stop the travel of your router plate. It's as simple as this. If you have a plunge router, you can set up 2 stop blocks, one in that position and one further back here, so you can control both ends of the trench, and you can have a double blind entry trench or an elongated mortise. That's the way you do staircase stringers. More on that in a few moments. If you're working with particle board which is bowed, like this piece, of course that will change the depth of your trench from one end to the other. There's a good way of rectifying it. Get 1 or 2 carpenter's clamps like this. Preferably look for ones with a shallow head, and you may have to file off a protrusion on the bottom so that you can separate the 2 parts of the clamp. Then you can place this part of the clamp through the center slot in the table and the rest of it up from underneath, and lock it in position and flatten out your bow in the sheet. And you'll find that if that goes through the center slot in the table, the router cutter will quite clearly miss it, because the cutter passes through about this point here. And you can even use 2 of these, one from this side and one from that side. This next router setup illustrates a couple of important points. I'm set up to do staircase stringers, for example. Now you'll be working with long, heavy pieces, so make sure you've got good outboard support. Either use a Triton extension table or a trestle or 2. Use the Triton protractor, the mitre gauge, to set your angle. But don't try resting a long, heavy piece against the mitre gauge. It's not quite long enough to give you good support. So use it to set the angle of a piece of scrap which you clamp firmly to the table. Before you put your stringer in, make a little notch in your scrap. That's your sighting point. You'll find that sighting up is quite difficult with a router, and this will help you immensely. Because a staircase stringer requires stop trenches, you shouldn't go all the way through. You'll need a stop block there, a stop block here, and of course clamp your work down. Even though it's a heavy piece, it still needs to be clamped down to the Triton table. But then a staircase stringer can be made as easily as this. Clamp it back up, line up this edge with the line, and then do your second cut. This method can of course be used for making smaller work like louvers, or anything where you need to route a trench on the incline. Because of the sighting difficulties you'll encounter in using a router, we strongly recommend that you make up a permanent routing platform. Now, do you remember the bevel cross-cutting platform we made earlier? Well, that doubles excellently for routing because it gives you the packing support, it gives you a higher fence to rest your work against. I've got sandpaper on the fence to stop the material from creeping and minimise the need for clamping, and a notch at this point will enable me to sight up router cuts perfectly every time. The direction of rotation of the router cutter is critical, especially when using the router upside down in the shaper mode, but even in the overhead router mode it should be considered. Very simply put, the router, when viewed from above, travels in a clockwise direction. Now, if you're trying to creep up the right-hand line with a router going in a clockwise direction, and you've got a small amount to remove to come up to that right-hand line, then there's a real danger that the router cutter will climb up on the work, try to bite off more than it can chew, and end up by giving you a ragged cut or by forcing the material sideways. So it's always best, if you can, if you're doing a trench which is wider than the cutter will do in one pass, to start off on the right-hand line, right on it, and then move your way across to the left-hand line. Very simply like this. You line up your pencil mark with the edge of your notch, and then make your first cut. Just a couple of quick points about that sighting notch. Firstly, if you change router cutters, let's say you put a narrower diameter cutter in, then of course the notch won't be quite as effective. You'll have to make a new fence. And secondly, it doesn't really matter operationally which way around you put your router in, that way or this way. But unless you've got your router mounted spot on, dead center on this plate, then it will make a difference to your notch. So always put your router in the same way, just in case you're slightly off center, and you won't damage that notch or recut that notch on your first pass. All of the cuts I've done so far with the router have been in particle board, which is fairly free cutting. Cutting hardwood is a little more difficult. Here's a sample piece. For example, hardwood is likely to splinter on the outcut. The way to rectify that, as mentioned earlier, is to have a backup board immediately behind the piece of wood that you're trenching. It'll be a sacrificial board, you'll cut into it, but at least it'll save the workpiece from splintering. And secondly, don't try to go down too deeply. If you want to make a trench this deep, make it in 3 or 4 steps. Do it incrementally, and your cutters will last longer, the wood will be less likely to creep out sideways, and you'll end up with a better job. Don't be overly concerned about the slight beard that routing can throw up in hardwood. This is unavoidable, but it very easily sands off. When using the router upside down in the shaper mode, the direction of rotation of the cutter is absolutely critical. Until you become more familiar with the machine, I suggest it's a good idea to put a couple of arrowheads on your Triton table to show you which way the cutter turns. Just mark them on there, and they'll serve as a reminder to you. It's very important that you always feed against the direction of rotation of the cutter, never with it. Let me illustrate what I mean. If you wanted to take a piece of wood like this and dress a small amount off this outside face, it would be very dangerous to pass the wood between the fence and the router cutter like this, because you'd be feeding with the direction of rotation of the cutter. The cutter would climb up on the work and rip the piece of wood out of your hands at a very high speed. There's a way to do it, and you'll see that in a few moments. Generally speaking, you should always try to keep the router cutter concealed within the 2 fences, between the 2 fences, so that you're prevented from straying onto the wrong side of the cutter, and you'll always be feeding against the direction of rotation of the cutter. If, for example, you wanted to do a trench within the body of the wood, or a groove rather, then you can lower the router cutter like that, and then you can pass the wood through, because there is no chance of that cutter flexing aside. It's completely buried within the piece of wood, and then you can pass the wood largely between the cutter and the fence. Let's say you want to do an edge rebate right there on the edge of a piece of wood. Okay,
Set your fences in until the router cutter is substantially nestling between them, and then by turning the cutter around and getting the maximum arc of the cutter, you can touch that to your pencil line there, and you can raise and lower your router cutter suitably to the correct height, and then you're almost ready to go. Always fit the safety guard where possible. With the router, this just tilts up when you push the wood underneath. Don't trail your fingers behind the workpiece. It's a very common cause of injury. Keep your hands clearly in view and above the work. Make sure the fence is nice and tight. You must always use the fence when using the router upside down, because otherwise you just cannot get a straight line. Always use the fence, make sure it's tight, but it doesn't always have to be exactly parallel. Here's an important distinction between the router use and the saw table use. Because the router is effectively a point cutting source and the saw blade is a disc, you're no longer required to keep the router fence exactly parallel. If the model router table you have has calibration scales on it, then use the scales as a reference point only, but you don't have to be too worried whether they read the same in both windows, as long as at the point where you're comparing the cutter to the wood, it looks correct. Lower the safety guard, keep the hands firmly on top of the work, switch on and make the cut. The feed rate is very important when using the router. You shouldn't go too fast, nor should you go too slow. If you've got any burn marks along the work, you're probably going too slowly. If you've got a lot of splintering and tearing, you're probably going too quickly. You'll have to experiment with different cutters and different materials. The hole in the router table is left quite large, so you can use fairly large diameter bits. But when you're using a smaller bit, it's a very good idea to adjust the fences inwards. If you've got this model router table, make yourself up 2 wooden sub-fences that you can screw on and adjust them in so just a bare minimum of cutter is showing. If you've got an older model router table, the fences are themselves adjustable. But lock those fences in position, and then you can adjust your cutter to the right depth of the material you'll be planing. And that is so that the cutter only just protrudes through the material. Now you can remove your workpiece, take a straight edge and move the rear router fence in line with the maximum arc of the cutter. So turn the cutter by hand until this tooth is closest to you, put your straight edge in and adjust the rear fence until the straight edge is just touching the fence and the cutter when it's swinging around, and turn it by hand like so. Now you have to set a differential between your front and rear fence. Very simply, use a calibration scale stamped in the front fence. They're 2 millimeters apart. Just trial lock that. Now take a straight edge and just double check that the gap you've got in there is exactly parallel all the way. Tiny bit of increase there. Okay, now that gap represents the amount you will plane off with each pass. As you can probably imagine, the setup we've got here now resembles a giant planer on its side, with a front shoe, a rear shoe, a gap between them, and the cutter buried quite between the 2 shoes. Now, incidentally, you cannot fit a power plane at the work centre or at the router table. There are too many difficulties in mounting it and guarding it. You can get equally good results, or better results, in fact, using a cutter this way or using a saw blade. Now, turning out the planing job I want to do, for example, a piece of veneered particle board often has a shattered edge left by the saw blade. Set up like this, I can very easily plane that edge off, fit the safety guard, keep fingers well clear, keep the hands on top of the work and press the work down onto the table, not too hard but firmly, switch on and make the cut. That's now left a perfectly smooth edge.
and I've taken off the amount represented by the differential between the fences. As you can see from this sample piece, the rear fence acts as a catcher once the workpiece has passed the router cutter. You may want to file a chamfer onto the leading edge of the rear sub-fence to make sure you don't get hung up on this point as you're passing the cutter. Now, that's quite straightforward when you're cutting all the way through a workpiece. What happens if you wanted to machine a wide face and you needed to do it in 2 passes? Well, then you have a different setup. Firstly, you set the 2 fences dead in line. Set them up so that they're exactly in line with the straight edge again, and then move the whole fence back until the amount you want to plane off is represented by the gap between a straight edge and the 2 fences, just like that. Make sure that gap's fairly even, and that's how much you'll plane off in the first pass only. You can often fit the safety guard. You may have to give it a bit of a leading, bit of a hand to start, but then you can run the piece of work through like this. Now, for doing the second pass, we'll be removing the small piece of wood in there, which is actually your support surface against the fences. You must set up the rear fence as a catcher. Adjust the whole fence until you can just turn the cutter and it's just touching the straight edge. Fine, lock that in position. And now set a differential in your front fence so that you're removing just the right amount of wood. Here we are. Make sure the front fence is parallel, check on the calibration scales, fit the safety guard, and you're ready for the second cut. And the rear face in that instance acted as a catcher, and you can do the cut easily and effortlessly. When making mortise and tenon joints, you'll save yourself a lot of effort if you make the mortises first with a single pass of your router and then make your tenons to suit. Very simply, all you do is attach a long, straight, high extension fence to your router fences. That'll give you good vertical support, because to make the mortises, you must plunge the work onto the bit. For a trial, get an off-cut of the material you'll be using, set the router cutter just protruding above the table, just a little way up will do, and by eyeballing from above, adjust the fence in or out until the router cutter is exactly central on the end grain of the piece of wood. Now that looks fine from here. You can now do a test cut, pull back, switch on, and plunge the wood onto the cutter. And now you can check either by eye or with a ruler that that dimension and that dimension are equal. Adjust the fence if not until you've got a perfectly central mortise. The next trick is to determine the length of the mortise and the starting and finishing point. I find it very helpful to do this. Take a square, turn the router to its maximum arc position, just like that, and make a pencil or pen mark on the table, and do the same at the other end of the cutter, so you have defined the limits of the cutter itself on your work table. Then let's say you want to make a mortise to suit a tenon of approximately these dimensions. That measurement there from the edge is 10 millimeters, okay? Make another mark, 10 mil from the forward line, and that's your starting point. Now determine how long a mortise you want. In this case, this is 50 mil. Now deduct the diameter of the cutter from that 50 mil. So 50 less 13 is 37. Make another mark, 37 millimeters further along on the table. Don't make the mistake of adding in the cutter diameter twice, because it makes a hole and then makes a slot as well. So deduct the cutter diameter from the length of mortise. And then very simply, you can attach your stop blocks. For setting the stop blocks, firstly lower your router cutter, get it down below table level, place your wood against this line here, that's your starting point, clamp a stop block on the back. G-clamp that in position. Now move the workpiece forward to the front line. Without bumping the workpiece, clamp another piece on, another stop block. Now here's a hint. Don't have your stop blocks coming all the way down to table level because sawdust could pack up in there and give you a false reading. Give the sawdust a bit of escape underneath, front and back. Blocks are set, you're almost ready to go. Raise the router cutter a small amount. Don't be too ambitious. Don't try to go in too deeply. If you try to make a deep mortise in one pass, you'll splinter the workpiece, you'll damage your router cutter, and you'll have a really hard time. So raise the cutter just a small amount, have the wood firmly against the back block, angle it up, rehearse the cut if you wish, then switch on and make the first cut. That's actually a perfect fit, but if it wasn't, you could reset the blocks and then go through and start making that a bit deeper. As I said, you do it in a series of passes, and this is a good way of seeing how deep you're going. Just sit it back up and raise the cutter until you've got, say, another 5 mil of lift there. Now clearly, when you're making mortars and tenon joints, you're not just doing one of them, you might be doing 8, for example. So don't keep going up and down with your router cutter. Do all 8 pieces at each of your router cutter settings. One last point on mortise and tenoning. Don't go to all the effort of chiseling those mortises square. It's unnecessary. It's much easier to round the tenons off, much easier to do that with a rasp, and then your mortise and tenon joints should fit absolutely perfectly. I mentioned during the section on bevel ripping that you can get excellent results with a 45-degree router cutter like this one. To use it, you have the fences dead in line, so get a straight edge and set them up. And slightly more than half of the router cutter must be buried behind the fences, with less than half of it forward of the fences. But have a look at what happens if I try to use this maximum cut and try to put a 45-degree bevel on this piece of hardwood in one pass. It's doing the job okay, but I'm overloading the router. You could hear the motor protesting. I'm overloading the cutter and splintering the wood. The way to do this is again in a series of bites. Move the fence in, closer to you, and take off a small pass. That's given a perfect face, and now move the fence out a little bit, do another pass, and out again if necessary for the final pass. Working along or against the grain with a shaper bit is normally quite okay, although you will get some splintering perhaps if you try to take too much off. But working across the grain, you're almost certain to get some splintering unless you take some precautions. Now you may want to consider at all times for the cross grain work, convert back to your saw table, put your circular saw in with the blade angled at 45 degrees in a cross-cut mode and cut them off with your saw. But if you want to use a router, here's how you should do it. Take the piece of wood that you'll be routing. Certainly do this in several shallow bites rather than one big deep bite. And use a pusher piece, a pusher block, a piece of scrap, directly behind the workpiece so that A, it helps you propel that along square against the fence, and B, it protects his back edge for the breakout when the router comes through that back edge. This is all you do. Take another bite. because of the loss of support when your workpiece is directly opposite the cutter, have these two sub-fences adjusted in as close as possible, but still allowing the router cutter to spin. As I mentioned earlier, there's a huge range of router cutters available, shaper cutters, with a ball bearing on top or a high-speed steel pilot. Now that acts as your fence. So you don't really need to use the fence on the Triton, but you should anyway, for safety reasons. Very simply put, the fence will prevent you from going onto the wrong side of the cutter, because if you feed the wood on this side of the cutter, you'll be feeding with the direction of rotation. The cutter will dig in and rip the piece of wood out of your hands, making it a projectile, and your hand could graze the cutter on the way through. So wherever possible, especially on straight pieces, have the fences in, have them a little bit back away from the high-speed steel pilot, just slightly behind it, and lock the fence in position. Then you can fit the safety guard. You'll still be able to use the ball bearing as your guide, but the fence is there to stop you from going too far onto the wrong side. Then put your wood in and very simply make a cut. If you find the material splintering during a full cut, or if the router's labouring or the router bit's smoking, for example, then use the fences and move it in for a partial cut. Do one cut at that setting, move the fence out a little bit, do another pass, and the final pass you can actually be riding on the pilot wheel. You can even shape quite small pieces, provided you hold them very firmly and move decisively. Always move against the direction of rotation with the cutter, never with it, always against. Now it's a good idea with a small piece like this to rehearse the cut. Place the guard in position, push it through and determine where your hands are going to be. Make sure your fingers are well out of range of the cutter, and just run through all four faces if that's what you're doing. Now it helps often, because of the breakout problem I mentioned earlier, to do the cross grain work first and then go with the grain, because then when you do the shaping along the grain you'll disguise any breakout you may have had with the cross grain work. So do them first, and do it again in a series of bites. Don't be too ambitious, don't try to go in too deep first off. You'll find the cross grain work might not be right on the first pass, but when you get it closer to the pilot, then you'll be just fine. A lot of people ask us whether you can make your own moulding on the Triton Workcentre. Well, certainly, provided you've got the router table and the appropriate router cutters. Safety warning though, moulding invariably is on a thin, flimsy piece of wood, and there's no room on that piece of wood for you to hang onto it and feed it through and have quite a substantial amount machined off it. What do? We'll start off with a larger piece of wood than you need, wider, and then you can run it through like so. And then if you wish, you can turn it around and run it through again, so you've moulded both edges of that piece of wood. And keep doing that until you've got enough piece of moulding, and then take your router off, put your saw back on, convert to table saw mode, and rip yourself off the two pieces of moulding that you want. Let's say you're trying to make something like this plaque. Now this has external curves, they're no problem. You can use the fences and the safety guard. It also has internal curves. Now they are a problem. This piece illustrates it more clearly. Quite clearly, with the fence in position, you just can't get into this area here because you're hung up on these points. So on these rare occasions, what you should do is move your fence out, not use it. Instead, use the pilot in its normal mode of operation. You'll have to hold the wood very firmly. And let's say you want the shaping to run from this point to this point only. Well, you'll have to plunge in at this point so that this point on the workpiece approaches a pilot at the point closest to you. Hold it firmly and resist any temptation for the router cutter to push you back this way. This way you'll be going in the same direction as the router cutter, and that's dangerous, so hold it very firmly, especially for the plunge in. If you've got a 1/2 inch capacity router and you've bought some very large router cutters which are too big to fit through the hole in the Triton table, there is a solution. Make yourself up a false top out of particle board or hardboard, no more than 1/2 inch thick. Cut yourself a big enough hole using a hole saw to admit the cutter, and then you can use it as normal and still use the fences and the safety guard, provided you make your board small enough to fit just between the two locking clamps. I hope you've learnt a lot during the course of this video, and that you too will become one of the tens of thousands of Triton owners who've got one of these machines, uses it properly, and raves about it because of its incredible versatility and accuracy. A couple of quick points before finishing. Firstly, fill in and send back your warranty registration certificate as soon as possible. There's no point hanging on to it in the hope of extending your warranty period. We do have records of serial numbers and the approximate date they were sold. So fill it in, give us some information about yourself and what you want to do on the Triton, and we will tailor our manufacturing processes to suit that as much as possible. Filling in the warranty coupon automatically gets you on our mailing list for details of new accessories and new products as they come out. We've just recently appointed an aftermarket manager whose job it is to look after you, Triton owners, and all of your particular needs in woodworking. For example, we're currently working on the project book, which is due out later in 1987, and we've got plans well in hand for a Triton Owners Club, which may take a year or two to get off the ground, but when it does come, I think you'll be delighted to be a member of it. Finally, we hope you're delighted with your Triton Workcentre, and if you are, why not share the good news with your friends? They might want to buy a Triton themselves. If you're not delighted, if you've got a problem, then please let us know about it, otherwise we can't help you. Contact us direct or contact us through your local agent. Happy Tritoning.